Hello there, and welcome to Midnight Geography. Tonight, we'll drift into the quiet geography of Minnesota, where water remembers ice. Minnesota is where the planet's ancient patience wrote itself in liquid. 10,000 lakes are not decoration, but memory. Each one a fingerprint left by glaciers that carved and retreated. This is geography that chose abundance over scarcity, holding more shoreline than ocean coasts within a landlocked body. It's where three watersheds meet, where water decides its destiny. If you enjoy these peaceful geographical explorations, consider liking and subscribing. It helps other curious minds find their way here too. But for now, let's begin. Lake Superior's Minnesota shoreline stretches for 189 miles along the state's northeastern edge, forming a coast where waves sound like ocean surf against bedrock that has witnessed more than 1 billion years. This is not merely old rock. It represents some of Earth's oldest exposed stone, thrust up from depths where the planet was still learning what it meant to have a surface. The waves arrive with the same patient rhythm as ocean tides. Though no moon pulls these waters, they simply rise and fall with wind and pressure, wearing against stone that was ancient when the first simple life appeared in Earth's seas. Stand here, and you stand at the edge of time itself, where geology becomes something more than science. It becomes a meditation on endurance, on what remains when everything else has worn away. The headwaters of the Mississippi River emerge from Lake Itasca in Clearwater County, where the continent's greatest river begins as something you could step across without wetting your knees. This narrow stream, barely deserving the name river, flows north before turning south on a journey that will carry it 2,500 miles to the Gulf of Mexico. But here, at the beginning, it is small and almost apologetic. A whisper that will become a shout, a trickle that will become a torrent. The moment of transformation from lake to river happens without ceremony, water simply choosing to move, to begin the long descent toward the sea. There is something humbling about witnessing the origin of greatness, about seeing where power begins in gentleness. The Mississippi will grow wide enough to carry barges and deep enough to hide mysteries, but it starts here, in quiet humility. Pipestone National Monument in southwestern Minnesota contains quarries of red catlinite stone that Native Americans have quarried continuously for at least 3,000 years. Think about that span of time. 3 millennia of human hands touching the same stone, generation after generation, returning to extract this sacred red rock. The quarries represent one of the longest continuously used mining sites in all of North America, a place where tradition and geology intersect across a time span that dwarfs nations and empires. The stone itself formed hundreds of millions of years ago, compressed from sediments in ancient seas, waiting all that time to be discovered by people who would see in its red color something sacred. The quarrying continues today under tribal management, the same techniques passed down through countless generations, the same prayers spoken over the extraction of stone destined to become ceremonial pipes. The Boundary Waters Canoe Area Wilderness contains over 1,200 miles of canoe routes, threading through more than 1,000 lakes, creating a landscape where the question becomes not where water is, but where it isn't. In many sections, water occupies more surface area than land, turning the usual relationship between earth and liquid inside out. This is a place that requires you to think differently about geography, to understand landscape not as solid ground with occasional water features, but as interconnected aquatic highways with occasional land interruptions. Paddlers can spend weeks here moving from lake to lake, portaging across narrow strips of land that serve merely as brief intermissions in the water's dominance. The routes follow paths first traveled by Ojibwe peoples, then by fur traders, then by anyone seeking to understand what it means when landscape becomes primarily liquid rather than solid. It's a geography that teaches humility. You move through it on water's terms, following channels carved by ice and maintained by flow. The North Shore hosts the only alpine-style mountains in the Midwest, the Sawtooth Mountains, where peaks rise nearly 1,000 feet above Lake Superior in less than 3 miles of horizontal distance. This is terrain that shouldn't exist here, mountains that have no business appearing in the middle of a continent better known for prairies and gentle hills. Yet here they stand at Cascade River State Park, their slopes steep enough to create a sense of verticality rare in these latitudes. The mountains rise from the lake shore with an urgency unusual for the patient geology of the Great Lakes region. They're not true alpine peaks, of course. They lack the glaciers and perpetual snow of western ranges, but they carry an alpine character in their steepness, in the way they force elevation gain over such short distances. Stand at the lake and look up, and the mountains seem to lean over you. Ancient volcanic formations that have resisted the leveling that time attempts to impose on all high places. The tiny town of Angle Inlet sits at the northernmost point of the contiguous United States, accessible only by boat, plane, or by driving through Canada. A geographical oddity created by treaty negotiators who drew borders without fully understanding the landscape they were dividing. At 49.3 degrees north latitude, it occupies a small peninsula jutting into Lake of the Woods, cut off from the rest of Minnesota by water on 3 sides and by Canadian territory on the 4th. The town exists in a kind of geographical isolation that modern infrastructure usually eliminates, a place where winter ice roads become the primary connection to the outside world when lakes freeze thick enough to bear vehicles. Fewer than 100 people live here year-round, maintaining a community that geography itself seems to argue against. Yet people persist, drawn perhaps by the very remoteness that makes life difficult, by the sense of living at the edge of what maps consider possible. Beneath Minneapolis lies a vast network of sandstone caves, carved by natural springs, and expanded during the 1800s for beer brewing and mushroom cultivation. The most famous of these are the Wabasha Street Caves, but they represent only a fraction of the hollow spaces beneath the city's streets and buildings. These caves formed naturally where groundwater dissolved soft sandstone, creating voids that early settlers discovered and enlarged for practical purposes. The temperature in these caves remains constant year-round, making them ideal for storing beer in the days before refrigeration, for growing mushrooms that thrived in the perpetual darkness and cool dampness. Today, many of these spaces are sealed, forgotten beneath the weight of modern development, but they remain, secret hollows underlying a city built on the assumption of solid ground. It's a reminder that landscape continues beneath our constructions, that the earth below maintains its own geography independent of what we build above. Lake of the Woods stretches across 1,485 square miles, containing over 14,000 islands, more islands than any other lake in the world, except for Canada's Great Slave Lake and Lake Huron. Imagine that. 14,000 separate pieces of land rising from these waters, each one its own small world surrounded by lake. The number itself becomes almost meaningless, too large to comprehend, too numerous to count in any practical sense. Some of these islands are large enough to have their own lakes, creating that rare geography of lakes within islands within lakes. Others are barely more than rocks, emergent stone that provides perches for birds and nothing more. The lake sprawls across the Canadian border, its waters shared between Minnesota and Ontario, its islands creating a maze that requires detailed navigation to traverse safely. To paddle here is to accept that you will never see all of it, that this is a landscape that exceeds human scale. The St. Louis River near Duluth drops 432 feet in elevation over just 75 miles, creating dozens of waterfalls, including the thundering cascades at Jay Cooke State Park. This is not the gentle descent of a mature river meandering toward its destination. This is a river in a hurry, dropping through ancient volcanic rock with an urgency that creates whitewater, spray, and the constant sound of falling water. The gradient is steep enough that the river has carved deep channels through bedrock, creating gorges where slate and granite walls rise on both sides, polished smooth by millennia of flowing water. At Jay Cooke, the river narrows and accelerates, forced through channels barely wide enough to contain its volume, creating rapids that speak of power, constrained but not controlled. The sound here is constant, a low roar that drowns out human voices, a reminder that water moving downhill carries force enough to reshape stone itself. Minnesota contains 3 continental divides meeting at Hill of Three Waters near Hibbing, where a single raindrop could theoretically split and flow to 3 different oceans. This is one of those geographical peculiarities that seems almost designed to make you stop and contemplate the nature of watersheds, of how water chooses its destination based on elevation differences measured in inches. From this point, water can flow north to Hudson Bay and the Arctic Ocean, east to Lake Superior, and eventually the Atlantic Ocean, or south through the Mississippi system to the Gulf of Mexico. The hill itself is unremarkable, a low rise that you might walk over without noticing, but it represents a convergence of continental-scale drainage patterns. A raindrop falling on one side begins a journey of thousands of miles to saltwater, while another falling just a few feet away embarks on an entirely different path to an entirely different ocean. Geography rarely offers such clear demonstrations of how small differences in place create vast differences in destiny. The Minnesota River Valley was carved by a catastrophic flood when glacial Lake Agassiz drained approximately 13,000 years ago, releasing water volume that dwarfed any flood in recorded human history. The valley this flood created is 5 miles wide in places, a scar across the landscape that now holds a river barely 100 yards across. Stand on the valley rim and look down at the modest river meandering through a space far too large for it, and you're seeing the ghost of that ancient catastrophe. The flood lasted perhaps only weeks or months, but it carved a valley that will exist for millions of years, a permanent reminder of temporary violence. The Minnesota River flows through this oversized valley like a child wearing a parent's coat, never quite filling the space that was made for something much larger. The valley walls rise on both sides, marking where the flood's waters reached, where unimaginable volumes of glacial meltwater surged southward toward what would eventually become the Mississippi. Mille Lacs Lake covers 132,000 acres with an average depth of only 15 feet, making it one of the largest shallow lakes in the United States. This is a lake where you can see the entire lake bed from above, where light penetrates all the way to the bottom across most of its surface, where shallow means not just wadeable, but visible. The shallowness creates a unique character. Waves build quickly when wind blows across miles of open water, but they never achieve the deep water power of lakes that plunge to great depths. In winter, ice forms early and thick, creating a surface firm enough to support entire villages of ice fishing houses. The lake's Ojibwe name means large lake, which it certainly is in area, if not in depth. Walleye thrive in these shallow waters, navigating an underwater landscape of sand, mud, and rock that extends for miles without dramatic depth changes. It's a lake that defies the usual association between size and depth, proving that vast doesn't necessarily mean deep. The Laurentian Divide runs diagonally across northern Minnesota from near Hibbing to the North Dakota border, separating waters flowing north to the Arctic Ocean from those flowing south to the Atlantic. This is one of North America's great hydrological boundaries, though unlike mountain ranges where divides follow dramatic ridgelines, here it crosses relatively gentle terrain. You can stand on the divide and see no obvious geographical reason why water should flow one direction on this side and another direction on that side. The land appears nearly level, the differences in elevation subtle enough to escape casual observation. Yet those subtle differences are enough to determine whether rainfall will eventually reach the ice-choked waters of Hudson Bay or the warm currents of the Gulf of Mexico. The divide is marked in places by modest signs, acknowledgments of this invisible line's importance, but mostly it passes unremarked, a continental-scale boundary that exists without drama, without fanfare, simply directing water according to the patient logic of gravity and elevation. Minnesota's prairie pothole region in the west contains thousands of small wetlands created by retreating glaciers, each depression a place where ice once sat, then melted, leaving behind a bowl that now fills with water seasonally or permanently. These potholes serve as critical breeding grounds for more than half of North America's waterfowl, creating an ecosystem that birds depend on for nesting, feeding, and raising young. From the air, the region looks almost diseased, pockmarked with circular and oval depressions filled with water and vegetation, the landscape unable to present a smooth surface. But this roughness, this refusal to be level and uniform, creates habitat diversity essential for countless species. Many of these wetlands are small, some just an acre or two, but collectively they form one of the continent's most important bird nurseries. The potholes fill with snowmelt in spring, then gradually dry through summer, creating a constantly changing mosaic of wet and dry, open water, and emergent vegetation. It's a landscape that lives in the transitional zone between water and land, never fully committing to either state. The Mesabi Iron Range stretches 110 miles across northeastern Minnesota, containing rock formations 1.8 billion years old that once held the richest iron ore deposits ever discovered in North America. The ore formed in an ancient sea where iron-rich waters precipitated minerals in thick layers on the seafloor. Then pressure and time compressed these deposits into bands of nearly pure iron oxide. When miners discovered these deposits in the late 1800s, they found ore so rich it required minimal processing, iron content so high that the rock itself was sometimes over 60% metal. The range produced billions of tons of iron over more than a century of mining, helping build America's steel industry, helping construct skyscrapers and bridges and ships. Today, the open pit mines have become lakes, filling with groundwater and rain, creating artificial bodies of water hundreds of feet deep in places where miners once extracted ore. The rock formations remain, visible in mine walls and outcrops, their distinctive red and black bands marking where ancient chemistry created concentrations of wealth that would shape industrial history. Lake Minnetonka, near Minneapolis, contains 14,000 acres divided into 23 named bays, connected by narrow channels that create a labyrinth where some bays feel like separate lakes entirely. You can spend a day boating here and never retrace the same path, moving from bay to bay through passages barely wider than your boat, discovering new vistas around each turn. The lake's irregular shape means that distance becomes difficult to judge. 2 points that appear close on a map may require miles of navigation through various bays and channels to actually reach. Some bays are deep and cold, while others are shallow and warm, creating temperature variations that would seem impossible in a single body of water. The channels between bays sometimes narrow to the point where boats can barely pass, creating traffic problems on busy summer weekends when hundreds of craft try to navigate the same bottlenecks. It's a lake that rewards exploration but punishes assumptions, that offers new discoveries even to people who have boated its waters for decades. The Root River in southeastern Minnesota has carved a valley 400 feet deep through limestone and sandstone layers, creating the state's most dramatic bluff country outside of the Lake Superior region. This is landscape carved by water moving through rock over time spans that make human history seem like an eye blink. The river works patiently, dissolving limestone, undercutting layers, gradually deepening its valley through stone that formed in ancient seas hundreds of millions of years ago. The valley walls rise steep on both sides, covered in hardwood forest that turns brilliant colors in autumn, their slopes too steep for farming, too rough for easy development. The river itself flows clear over limestone and gravel beds, creating habitat for trout that require cold, clean water. Stand on the valley rim and look down at the river far below, and you're seeing the cumulative effect of countless small erosive actions, rain and freeze-thaw and simple dissolution, repeated over millennia until they add up to a canyon. Minnesota contains more shoreline than California, Florida, and Hawaii combined. 90,000 miles of lake and river edge, despite being entirely landlocked. This is one of those statistics that seems impossible at first, that requires you to stop and reconsider what you think you know about geography. But it's the result of fractal complexity. The more closely you measure, the longer the shoreline becomes. Every bay and inlet adds length. Every island perimeter multiplies the total. With more than 11,000 lakes, even small contributions add up to continental scale totals. This abundance of shoreline means that relatively few places in Minnesota sit far from water, that the state's identity is shaped fundamentally by the presence of liquid edges where land meets lake, where solid gives way to fluid. The shoreline isn't ocean coast with its regular wave action and sandy beaches. It's a more intimate relationship between earth and water, a quiet border where cattails grow and loons call and water laps gently against whatever shore the glaciers left behind. The Sudan Underground Mine State Park allows visitors to descend 2,300 feet below the surface into what was once the deepest iron mine in Minnesota, now repurposed for physics experiments studying some of the universe's most elusive particles. The descent takes place in the same cages that once carried miners to their work, dropping through rock layers that record nearly 2 billion years of geological history. At the bottom, the air is cool and still, the silence profound, broken only by the drip of water and the occasional sound of distant equipment. The rock around you is Ely greenstone, some of Minnesota's oldest stone, formed when volcanic islands dotted an ancient ocean that existed before most of the continent had assembled. Today, physicists use this deep location to shield sensitive detectors from cosmic rays, searching for neutrinos and dark matter in the same chambers where miners once extracted ore. It's a peculiar juxtaposition. The most cutting-edge science conducted in the most ancient rock, miles of stone overhead, blocking interference from above, while experiments probe the fundamental nature of the universe. Red Lake in northwestern Minnesota is the only lake in the lower 48 states where all the water and surrounding land belong to a single Native American tribe, the Red Lake Band of Chippewa. This is a rare preservation of indigenous sovereignty over a complete watershed, where tribal jurisdiction extends across both land and water, where governance and geography align in ways uncommon in the complicated history of American settlement. The lake is actually two lakes, Upper Red Lake and Lower Red Lake, connected by a short river, together forming Minnesota's largest lake entirely within state borders. The tribe manages the lake's resources, including its valuable walleye fishery, making decisions about harvest levels and conservation without the overlay of state or federal management that affects most other waters. It's a landscape where history took a slightly different path, where the usual pattern of dispossession didn't fully complete, leaving this island of tribal authority in a sea of ceded territories. The lake spreads vast and shallow under northern skies, its waters held not just by surrounding land, but by the laws and traditions of the people who never left. The St. Croix River forms 129 miles of Minnesota's eastern border with Wisconsin, flowing through a valley carved during the last ice age when glacial Lake Duluth drained catastrophically southward. This wasn't the gradual work of normal river erosion. This was violent, sudden, the release of an entire glacial lake through a narrow outlet. The flood scoured the valley deep, stripping away softer rock and leaving harder formations exposed as cliffs and outcrops. Today, the river flows peacefully through this oversized valley, its current modest compared to the torrent that first shaped its course. The valley walls rise on both sides, covered in forest that has reclaimed the bare rock the floodwaters exposed. Paddlers drift through scenery shaped by catastrophe, but maintained by calm, moving through a landscape where the dramatic origin story has been softened by millennia of normal weather, normal seasons, normal time. The river now serves as a boundary between states, but it existed long before those political divisions, flowing according to the logic of gravity and the memory of ice. Eagle Mountain rises 2,300 feet above sea level in Cook County, Minnesota's highest point, standing just 13 miles from Lake Superior's shore, which sits at 600 feet elevation. This proximity creates one of the state's most dramatic elevation changes over such a short distance. Climb Eagle Mountain, and you stand 1,700 feet above the lake you can see shimmering in the distance. The mountain isn't a peak in the alpine sense, no sharp summit reaching toward sky, but rather a high point on a rugged upland, the crest of terrain that rises steadily from the lakeshore. The rock here is ancient granite and gabbro, igneous formations that cooled from magma more than 1 billion years ago. To stand at the summit is to stand on stone that was molten when life on Earth consisted of single cells, when the atmosphere itself was still learning what composition would eventually allow complex life to emerge. The view stretches for miles when the weather cooperates, showing the extent of the Superior National Forest spreading in all directions, a landscape still largely as wild as it was before European contact. But often, the summit sits wrapped in cloud, moisture from the lake rising and condensing as it climbs the slope, creating conditions more Pacific Northwest than Upper Midwest. The Minnesota landscape rests on bedrock that varies in age from 3.6 billion years old in the Minnesota River Valley to 1.1 billion years old along Lake Superior's north shore. This span of time is difficult to comprehend. We're talking about rock that formed when Earth itself was less than 1 billion years old, when the planet was still settling into configurations that would eventually produce continents as we know them. The oldest rocks in the Minnesota River Valley represent some of the most ancient crust exposed anywhere on the planet's surface, stone that witnessed the earliest chapters of Earth's geological story. They formed in an environment utterly unlike today's world, different atmosphere, different ocean chemistry, no life beyond the simplest bacteria. The younger rocks along Lake Superior, though ancient by any human standard, are practically modern by comparison. Volcanic flows from a time when the continent was trying to split apart, when magma rose through cracks and spread across the surface in flows that would eventually stack hundreds of feet thick. To walk from the Minnesota River Valley to Lake Superior is to walk forward in geological time, moving through more than 2 billion years of Earth history written in stone. Leech Lake covers 102,000 acres with a shoreline so convoluted that measuring every bay and peninsula yields over 600 miles of coastline, more than the entire state of Rhode Island. This is the fractal nature of shorelines made manifest, the way complexity increases as measurement becomes more detailed. From a distance, the lake might appear to have a simple outline, but approach more closely, and bays reveal themselves, and within those bays are smaller indentations, and along those indentations are points and coves, and the total length keeps growing with each new level of detail you choose to include. The lake's name comes from a translation error. The Ojibwe name referred to the presence of leeches, but the translation became attached to the lake itself. Today it's known for walleye fishing and for the reservation lands of the Leech Lake Band of Ojibwe that surround much of its shore. The water is clear enough in places to see aquatic vegetation waving in the current, dark enough in others to suggest unknown depths. Islands dot the surface, some large enough to have seasonal homes, others barely big enough for a picnic. It's a lake that rewards exploration, that reveals new aspects depending on which bay you enter, which channel you follow, which shoreline you trace with your boat's wake. The Vermilion Range stretches 80 miles across the Arrowhead region, containing greenstone formations 2.7 billion years old that represent some of Earth's earliest volcanic island chains. These rocks formed in an ancient ocean, volcanic islands that eventually collided with and accreted onto the growing North American continent. The greenstone gets its name from its color, a result of metamorphism that transformed the original volcanic rock, changing its mineral composition while preserving its structure. Iron ore was discovered in these formations in the 1880s, leading to the development of Ely, Tower, and other mining towns. The mines went deep, following ore bodies down through rock layers that had lain undisturbed for billions of years. Today, many of those mines are closed, their shafts sealed or flooded, but the greenstone remains exposed in outcrops and road cuts, its distinctive color marking it as different from the surrounding geology. These rocks are witnesses to a time before most of Earth's current continents existed, before complex life had evolved, before even the oxygen in the atmosphere had accumulated to levels that would eventually allow animals to breathe. They're pieces of a world we can barely imagine, preserved through unimaginable time spans, now accessible to anyone who cares to stop and look. Minneapolis and St. Paul together contain 22 natural lakes within city limits, an unusual abundance of urban water that shapes both cities' characters and their residents' relationships with landscape. Cedar Lake in Minneapolis reaches depths of 51 feet, despite being surrounded by dense development. Its waters cold and clear enough for swimming, its shores lined with parks and walking paths. These aren't decorative ponds created by developers. They're glacial features, kettles and depressions left when ice blocks melted, genuine geological formations that happened to survive the urban expansion that surrounded them. Some of these lakes are connected by creeks and channels, creating networks where water flows from one to another. Others stand isolated, self-contained ecosystems maintaining their own water chemistry and biology despite the pavement and buildings pressing in from all sides. The presence of these lakes means that even in the urban core, people encounter water regularly, see how it changes with seasons, watch it freeze and thaw, ripple in wind, reflect sky. They provide habitat for waterfowl and fish, cooling for summer heat, beauty for daily life. They're reminders that landscape persists beneath and within civilization, that geography continues regardless of human construction, that the Ice Age shaped these cities as surely as any city planner. The Minnesota portion of Voyageurs National Park preserves 218,000 acres, where water covers 40% of the park's surface, creating a landscape accessible primarily by boat rather than road. This inversion of the normal relationship between water and land changes how visitors experience the park, how they navigate its geography, how they understand its scale. Roads exist only at the margins. To truly enter Voyageurs, you must travel by watercraft, following channels between islands, crossing open expanses where waves can build to surprising heights, threading through narrows where rock walls close in on both sides. The park protects the transition zone between northern forest and boreal landscape, a place where species from different ecological communities mix and overlap. But it's the water that defines everything here, the interconnected lakes and channels that have served as highways for thousands of years, first for indigenous peoples, then for fur traders, then for loggers, now for anyone seeking to understand what landscape looks like when water rather than land provides the primary connections. In winter, the lakes freeze solid enough to support snowmobiles, creating temporary roads that disappear come spring thaw. The park exists in two states, summer liquid, winter solid, each season offering entirely different ways to experience the same geography. Mystery Cave near Harmony extends for at least 13 miles underground, through limestone caverns where an underground river maintains a constant 48 degrees Fahrenheit year-round. The cave formed as slightly acidic groundwater, percolated through cracks in 450-million-year-old limestone, gradually dissolving the rock and creating void spaces that eventually connected into passages large enough for humans to explore. The process took millions of years, each drop of water removing a tiny amount of dissolved calcium carbonate, the cumulative effect creating chambers and tunnels that honeycomb the subsurface. The underground river still flows, still works on enlarging the passages, though at a pace too slow for any human observer to notice. The water emerges at springs downstream, having traveled through darkness for distances we can only partially map. The cave remains a constant temperature because it sits deep enough that surface weather changes don't penetrate, deep enough that the rock's thermal mass overwhelms any seasonal variation. To enter is to leave behind not just daylight, but all the fluctuations that define surface life. Temperature, humidity, light levels, all become constant in the cave's unchanging environment. The formations here, stalactites and stalagmites, flowstone and draperies, grow at rates measured in centuries per inch, patient mineral construction that continues whether anyone observes it or not. The Kettle River flows 90 miles through eastern Minnesota, cutting through bedrock formations that include 1.1 billion-year-old sandstone, visible at Banning State Park's Hell's Gate Rapids. The river drops through ancient volcanic terrain, its course determined by fractures and weaknesses in rock that has resisted erosion for over 1 billion years. At Hell's Gate, the river narrows dramatically, forced through a channel carved deep into the sandstone, creating rapids that speak of the river's power when spring melt swells its volume. The sandstone here shows crossbedding and ripple marks, evidence that it formed as sand in an ancient stream or river, meaning this is riverine rock carved by a modern river, water cutting through deposits left by water that flowed more than 1 billion years ago. The layers tell stories of ancient currents, of floods and low water, of sandbars that shifted and reformed over millennia before pressure and time turned loose sand into solid stone. Today's river pays no attention to those ancient waters. It simply follows the path of least resistance downhill, carving ever deeper through whatever rock lies in its path, adding its own chapter to a story that spans geological ages. Minnesota's northwestern corner once lay beneath glacial Lake Agassiz, a prehistoric lake larger than all 5 Great Lakes combined that existed from 11,700 to 9,000 years ago. Imagine a body of water covering an area roughly the size of the Black Sea, spreading across what is now Manitoba, Ontario, Saskatchewan, Minnesota, and North Dakota. The lake formed when glacial meltwater became trapped between the retreating ice sheet to the north and higher ground to the south, creating a temporary inland sea that persisted for thousands of years. The lake's beaches are still visible in some places as subtle ridges crossing the landscape, ancient shorelines now miles from any water. When the lake finally drained, sometimes gradually, sometimes in catastrophic floods as ice dams broke, it left behind some of the flattest, most fertile land in North America. The clay and silt that settled in the lake's quiet waters now form the rich agricultural soils of the Red River Valley. The lake bed is so flat that water drains slowly, leading to frequent flooding when spring melt has nowhere to go quickly. This is landscape shaped by the presence of water that no longer exists, by a lake that left its mark in soil composition and surface flatness even after the water found its way to the ocean. The Minneapolis chain of lakes, Calhoun, Harriet, Cedar, Isles, and Brownie, are connected by channels and creeks, creating a 13-mile water trail through the heart of the city. These lakes represent glacial kettles left when massive ice blocks, separated from the retreating glacier, became buried in sediment, then slowly melted to create depressions that filled with water. The fact that they survived urban development is somewhat remarkable. Many cities filled such features or used them as drainage basins, but Minneapolis preserved them, built parks around them, created a system that allows people to canoe or kayak from one lake to another without ever leaving the water. Each lake has its own character, some deep and cold, others shallow and warm, some circled by paths crowded with walkers and cyclists, others quieter and more contemplative. In winter, they freeze solid, their surfaces becoming ice rinks and cross-country ski trails. In summer, they're dotted with sailboats and paddleboards, swimmers and anglers. The channels connecting them are narrow enough that you can almost touch both banks at once, intimate passages between larger open waters. This chain of lakes means that even in the urban core, landscape remains present. Water continues its cycles, seasons mark themselves in ice and thaw, and geography persists underneath and within the city built around it. Split Rock Lighthouse stands on a 130-foot cliff of volcanic rock on Lake Superior's north shore, positioned where billion-year-old lava flows form some of the most dramatic coastal scenery in the Midwest. The lighthouse was built after a devastating storm in 1905 that wrecked more than 30 ships on Lake Superior, a reminder that these waters can become as dangerous as any ocean despite the lake's lack of tides. The cliff is dark gray basalt, part of the North Shore volcanic group, layer upon layer of ancient lava that flowed across this landscape when the continent was attempting to rift apart. The attempt failed. The rift never completed, but it left behind this impressive stack of volcanic rocks. The lighthouse sits high enough that its beacon could be seen for 20 miles across open water, guiding ships through waters where navigation was complicated by fog, storm, and the treacherous iron-bound coast where ships that ran aground often broke apart on the rocks. Today, the lighthouse no longer operates. GPS and modern navigation have rendered its beacon obsolete, but it remains as a historic site, a marker of the relationship between humans and this unforgiving shoreline, a reminder that these waters demand respect and careful attention from anyone who ventures onto their surface. The Cannon River drops 500 feet in elevation as it winds 110 miles from its headwaters near Faribault to its confluence with the Mississippi River, creating several significant waterfalls along its course. This is a river in a hurry, descending through layers of limestone and sandstone, exploiting weaknesses in the bedrock to carve its path toward the larger river. The name comes from a French word for tube or pipe, though the exact origin of the naming remains unclear. What's clear is that the river's gradient creates energy, power that 19th century millers harnessed to grind grain and saw lumber, building their mills wherever the river fell over ledges of resistant rock. Many of these old mill sites remain visible today, though the mills themselves have largely vanished. Their stone foundations and dam ruins, the only evidence of once thriving industry. The river continues its work, slowly eroding upstream, undercutting the waterfalls inch by inch, century by century, gradually dismantling the rock formations that create the falls themselves. It's a process that will continue long after the last human structure has crumbled. Water, following gravity's command, wearing stone with patience that exceeds any human understanding of time. The waterfalls exist in a moment of geological time, temporary features that will eventually erode away, though that moment stretches across thousands of human generations. Lake Pepin forms a natural widening of the Mississippi River between Minnesota and Wisconsin, stretching 22 miles long and up to 3 miles wide, created where the Chippewa River's sediment dammed the Mississippi. This damming wasn't intentional or artificial. It's simply the result of one river depositing material faster than another river can carry it away. The Chippewa built a delta where it entered the Mississippi, and that delta acted as a natural dam, backing up water upstream and creating this lake. It's one of the few true natural lakes on the Mississippi River, a place where the river forgets itself temporarily, spreading wide and relatively still before gathering itself back together downstream. The lake is deep enough for substantial waves when wind blows down its length, creating conditions that feel more like Great Lakes sailing than river navigation. In winter it freezes, though the thickness varies, and ice roads are treated with respect and caution. The bluffs rise high on both sides, Wisconsin on the east, Minnesota on the west, their limestone and sandstone faces marking the river's ancient valley. These bluffs stood here long before the lake formed, have watched the river change its character multiple times as glaciers advanced and retreated, as climate shifted, as the land itself rose and fell in response to the weight and release of continental ice. The dalles of the St. Croix River form a narrow gorge where 200-foot basalt cliffs squeeze the river into a channel only 200 feet wide, creating swift currents through 550 million-year-old volcanic rock. This isn't the river's doing. The gorge formed along a geological weakness, a place where the rock was fractured or faulted and thus more susceptible to erosion. The river simply found this weakness and exploited it, carving ever deeper through the basalt that formed from lava flows in an ancient rift system. The rock is dark and dense, hard enough that the river has made slow progress despite thousands of years of flow. The dalles create a dramatic narrowing, the river compressed and accelerated, its surface disturbed by eddies and boils where current patterns intersect. Indigenous peoples recognize this as a significant place. The name Dalles comes from French voyageurs, but the location itself was known and named long before European contact. The vertical walls of the gorge create a sense of enclosure unusual on this otherwise broad river, a place where the scale suddenly shifts from expansive to intimate, where rock walls lean in and the sky becomes a ribbon overhead rather than a dome. To paddle through the Dalles is to experience the river at its most constrained, its personality compressed into intensity by the narrowness of the channel it's forced through. Minnesota contains portions of 3 major biomes: northern coniferous forest, deciduous hardwood forest, and tallgrass prairie, making it one of the most ecologically diverse states in the nation. These biomes meet and overlap in transitional zones where species from different communities mingle, where you might find prairie plants growing in oak savanna, where conifer species extend south along cold river valleys into primarily deciduous terrain. This diversity reflects Minnesota's position at a continental crossroads, where northern species reach their southern limits, where southern species reach their northern limits, where eastern forest meets western grassland. Climate determines much of this distribution. Temperature and precipitation patterns create conditions suitable for different plant communities, but soil and topography matter too, creating local variations that allow unexpected species to persist in unlikely places. The result is a state where driving a few hours can take you through dramatically different landscapes, where the vegetation visible from the highway shifts from pine forest to oak woodland to remnant prairie. This diversity once supported corresponding diversity in wildlife, though human modification of the landscape has reduced populations of many species while allowing others to thrive in agricultural and suburban environments. But the fundamental pattern remains. Minnesota sits where different biological regions meet, creating richness and complexity that purely northern or purely prairie states cannot match. The Blue Mounds in southwestern Minnesota rise 100 feet above the surrounding prairie, formed by a ridge of pink Sioux quartzite that has resisted erosion for 1.6 billion years. This rock is older than almost anything else visible at the surface in southern Minnesota, harder than the limestone and sandstone that surround it, resistant enough to stand proud when softer rocks have eroded away. The quartzite formed from sand deposited in an ancient sea, then subjected to heat and pressure that recrystallized the sand grains into a rock harder than the original sandstone. The pink color comes from iron oxide minerals distributed through the rock, the same iron that gives rust its color, here incorporated into stone that will last for millions of years more. The mounds run roughly north-south, an alignment that some believe explains their name. From certain angles, when atmospheric conditions are right, the rock face appears blue from a distance. But the name might also come from the blue-green lichens that grow on the rock, or from the appearance of the cliff at sunset when shadows turn the eastern face dark blue-gray. Whatever the origin of the name, the mounds stand as an island of ancient rock surrounded by much younger deposits, a window into deep geological time rising above prairie that is itself relatively recent, having developed only after the last glaciers retreated and climate shifted to favor grasslands over forests. Rainy Lake on Minnesota's northern border contains 1,600 islands scattered across 360 square miles of water, with depths reaching 161 feet in some sections. The islands range from tiny rock outcrops barely large enough for a single tree to substantial landmasses with their own interior lakes, creating a complexity that makes navigation challenging without detailed maps. The lake's name supposedly comes from the mist that rises from Rainy River's falls, though by the time French voyageurs arrived to give it the name that would stick, the Ojibwe had long called it by names that reference the territory and travel routes it represented. The lake straddles the international border, shared between Minnesota and Ontario, its waters mixing without regard for political boundaries. In the voyageur era, this was a major waypoint on canoe routes heading west and north, a place where expeditions paused to rest and resupply before continuing deeper into the continent. Today, it's known for fishing: walleye, northern pike, smallmouth bass, species that thrive in the clear waters and rocky structure the glaciers created. The clarity of the water varies with location. Some areas are stained dark with tannins from northern bogs, while others run clear enough to see 20 feet down to the rocky bottom, where ancient stone worn smooth by ice still shows the scratches and grooves left by rocks embedded in glacial ice grinding across the bedrock. The Minnesota River flows 335 miles in a path that roughly traces the southern border of the last major glacier advanced 12,000 years ago, marking where ice sheet met open land. This positioning isn't coincidental. The river occupies the valley carved by glacial River Warren, which drained Lake Agassiz in a catastrophic flood. But even before that flood, this area represented a boundary between glaciated and unglaciated terrain, between landscape recently scoured by ice and land that had experienced thousands of years of normal weathering and erosion. The river today is turbid, carrying substantial sediment loads from agricultural runoff in its watershed, its water often brown or yellow depending on recent rainfall. This turbidity represents the reworking of glacial deposits, silt and clay left by the ice sheet now washing slowly toward the Mississippi and eventually the Gulf of Mexico. The river's valley is disproportionately large for the river it contains, a persistent reminder that this landscape was shaped by water volumes far exceeding anything the modern river achieves. The valley walls are visible for most of the river's length, rising abruptly from the floodplain to mark where the catastrophic flood reached, where the temporary torrent carved its channel through whatever stood in its path. To follow the Minnesota River is to trace the edge of glaciation, to travel along a boundary that defined landscape character for the entire late Pleistocene epoch. High Falls at Tetagauche State Park drops 70 feet over volcanic bedrock, making it one of Minnesota's tallest waterfalls on a river that reaches Lake Superior just a mile downstream. The falls occur where the Baptism River encounters a resistant layer of rhyolite, a volcanic rock that formed from silica-rich lava more than 1 billion years ago. The river has been working to erode through this rock for thousands of years, gradually cutting the gorge deeper, slowly extending the falls upstream in the inevitable pattern of waterfall retreat. The sound here is constant and encompassing, the roar of water falling, the spray that rises to coat nearby vegetation, the feel of power concentrated in a narrow space. Below the falls, the river continues through rapids and smaller cascades, dropping elevation quickly in its race toward the lake. The gorge walls show the layered structure of multiple lava flows, each flow representing a distinct volcanic event, separated by enough time for weathering to occur between eruptions. These layers are pages in a book of ancient volcanic activity, a record of the continent's attempt to split apart, an attempt that ultimately failed, but left behind this impressive legacy of igneous rock. To stand at the base of High Falls is to feel the weight of falling water, to sense the patient power that carves stone, to witness the ongoing work of erosion that will eventually reduce even these 70 feet to a series of rapids, though that transformation lies thousands of years in the future. The Lost 40 in the Chippewa National Forest was never logged because a 19th century surveying error incorrectly mapped it as being underwater, preserving 144 acres of old-growth red and white pines, up to 350 years old. The surveyors somehow placed the land in the wrong location on their maps, marking solid ground as part of a lake. When timber companies bought logging rights based on those maps, they skipped this area, assuming water rather than merchantable timber. By the time the error was discovered, conservation attitudes had shifted enough that the trees were preserved rather than cut. Today, these pines stand as witnesses to what Minnesota's forests looked like before industrial logging transformed the landscape. Some of the trees measure 5 feet in diameter, their trunks rising straight and branchless for the first 50 feet before spreading canopy. The forest floor beneath them is dim even on sunny days, the dense canopy intercepting most light before it reaches the ground. Walking here feels like entering a cathedral. The vertical lines of the trunks, the height of the canopy, the hushed quality of sound absorbed by bark and needles. These trees were already mature when the United States became a nation, were seedlings when European contact with the Americas was still new. They survived not because anyone chose to protect them, but because an error on a map created a space where history unfolded differently, where cutting never happened, where old growth remained simply by accident and inattention. Gooseberry Falls State Park contains 5 waterfalls where the Gooseberry River drops 200 feet in elevation within the final mile before entering Lake Superior. The falls cascade over volcanic rock in a series of drops and slides, each one distinct in character, some plunging straight down, others sliding across tilted bedrock, still others splitting into multiple channels that rejoin downstream. The middle falls are the most dramatic, dropping in 2 stages with a pool between, the water white with aeration as it tumbles over the edge. The sound varies depending on flow. During spring, melt the falls roar with volume, while in late summer they whisper across rock faces that show bare in places. The bedrock is dark basalt, part of the same volcanic flows that built the North Shore's dramatic topography. Water has polished some surfaces smooth while leaving others rough and fractured, creating textures that guide flow in specific patterns. Below the lower falls, the river enters Lake Superior across a cobble beach where waves sort stones by size and shape with each surge and retreat. The park sits at the transition between river and lake, between downhill flow and horizontal expanse, between the river's urgency and the lake's patient acceptance of whatever waters reach it. Visitors come to see the falls, but the real story is the relationship between water and rock here. How the river exploits weaknesses, how the resistant bedrock determines where falls occur, how erosion works upstream gradually, reshaping the landscape inch by inch across timescales that exceed human observation. The Boundary Waters Wilderness and Quetico Provincial Park together form 2.5 million acres of continuous protected wilderness straddling the Minnesota-Ontario border, the largest such protected area in the eastern half of North America. This is landscape where roads are absent, where travel occurs by canoe and portage, where the sound of motors is prohibited and silence is policy as much as geography. The wilderness extends far enough that you can paddle for weeks without retracing routes, moving through chains of lakes connected by rivers and separated by portage trails worn smooth by centuries of feet carrying canoes overhead. The forest is primarily boreal, black spruce and jack pine, aspen and paper birch, species adapted to cold winters and short growing seasons, to poor soils and frequent fire. The rock beneath is ancient Canadian shield, granite and greenstone worn to low relief by ice and time. This isn't dramatic mountain scenery, but something subtler. Low ridges, countless lakes, forest that covers everything not currently underwater. The wilderness exists because both nations decided that some landscapes should remain unroaded, undeveloped, accessible only to those willing to travel by human power through terrain that yields no profit beyond the experience of moving through it. The protection extends across a political border that matters to nations, but means nothing to the wolves and moose, to the loons whose calls echo across lakes, to the water that flows according to topography, regardless of which country claims it. Lake Vermilion's shoreline measures 365 miles around 1,200 islands and countless bays, creating a shape so irregular that the lake's 40,000 acres of water seem much larger. The complexity is fractal. Each bay contains smaller indentations. Each island creates passages that multiply the edge where water meets land. Each peninsula branches into sub-peninsulas until the total length of shoreline becomes almost absurd. You could spend a week boating here and barely scratch the surface, never seeing all the bays and channels, never exploring all the islands. Some of these islands are substantial, with cabins and docks and trees enough to make them feel like destinations. Others are barely more than rocks with a few wind-stunted pines clinging to thin soil. The water varies in color, clear green in some bays, dark brown in others, where streams bring tannin-stained water from northern bogs. The lake occupies a basin carved in greenstone, ancient volcanic rock that gives the water its distinctive clarity in areas where the bottom is visible 20 feet down. Vermilion means red in French, though whether the name refers to sunset colors on the water or to iron-stained rocks remains unclear. The lake sits at the edge of the Boundary Waters region, connected by portage routes to the larger wilderness, but itself developed enough to have resorts and private cabins along some shores. It exists in transition, partway between the fully wild and the partially tamed, offering both solitude and access depending on which bay you choose to explore. The Gunflint Trail extends 57 miles from Grand Marais inland through the Superior National Forest, climbing 1,500 feet in elevation, while passing hundreds of lakes carved by glacial action. The trail, now a paved road but still carrying the name trail, follows a route that predates European contact, a path used by Ojibwe and before them by earlier peoples moving between Lake Superior and the interior. The name comes from the flint-like rock found along parts of the route, stone hard enough to strike sparks, useful for fire starting before matches existed. The road climbs gradually from the lakeshore, passing through terrain that transitions from boreal forest near Superior to a landscape of lakes and exposed granite at the higher elevations. Each mile inland brings you deeper into wilderness, farther from the moderating influence of the big lake, into country where winter comes earlier and stays later, where the growing season is measured in weeks rather than months. The lakes visible from the road are just a fraction of those that exist in this region. Most require hiking or paddling to reach, sitting in basins surrounded by forest, their existence marked on maps, but not visible from any road. The trail ends at the edge of the Boundary Waters, where pavement stops and water travel begins, where the machinery of civilization gives way to the older rhythms of paddle and portage. To drive the Gunflint Trail is to trace a line between accessibility and wildness, between the developed shore of Lake Superior and the roadless interior where landscape still determines how and where humans can travel. Minnehaha Falls in Minneapolis drops 53 feet over limestone ledges that have been eroding upstream at a rate of 4 feet per year for thousands of years, gradually carving the gorge deeper. The falls occur where Minnehaha Creek encounters a resistant layer of limestone overlying softer sandstone. Water flowing over the edge undermines the sandstone, causing the limestone to collapse periodically, creating the upstream migration typical of waterfalls. This process means the falls were once farther downstream, closer to the creek's junction with the Mississippi River, and will eventually erode far enough upstream to cease being a waterfall at all. But that transformation lies thousands of years in the future. For now, the falls remain, dropping into a gorge lined with vegetation that thrives in the constant spray and moisture. The name supposedly means laughing water in Dakota language, though the translation and attribution remain subjects of debate. Longfellow's poem, The Song of Hiawatha, popularized the name and location, though his description owed more to imagination than to actual geography. Today, the falls sit in a city park, accessible by paved paths, visited by thousands who come to see water falling in the heart of an urban area. The falls freeze partially in winter, creating ice formations that build up around the edges, while water continues to flow down the center, creating a temporary sculpture that melts away each spring. The constancy is the sound, the rushing of falling water, audible from surprising distances, a reminder that landscape continues its work, regardless of the city built around it. The Zumbro River watershed drains 1,428 square miles of southeastern Minnesota through a network that includes north, middle, and south branches converging near Rochester before flowing to the Mississippi. This is river as network, water collecting from hundreds of square miles of agricultural land, carrying not just rainfall, but everything that rainfall picks up as it moves across the landscape: sediment and nutrients, dissolved minerals, and whatever chemicals humans have applied to fields. The watershed is defined by subtle topography. This is not mountain drainage with obvious ridge lines marking boundaries, but gentle terrain where divides between watersheds are often barely perceptible rises. The three branches each have distinct characters, draining different geological terrain, carrying different sediment loads, flowing at different speeds depending on gradient and channel characteristics. Where they converge near Rochester, the combined flow becomes substantial, a river rather than a creek, with enough volume to cause significant flooding when spring melt or heavy rainfall exceed the channel's capacity. The word Zumbro is supposedly a corruption of a French name, though, like many river names in Minnesota, the exact etymology has been lost to time and imperfect translation. The river carved its valley through layers of limestone and sandstone, exposing rock formations that record ancient seas and coastal environments from hundreds of millions of years ago. Today, the river flows through a landscape transformed by agriculture, its banks often tilled to within feet of the water, its watershed almost entirely converted from oak savanna and prairie to corn and soybean fields. Inspiration Peak in Otter Tail County rises to 1,750 feet elevation, providing views across 150 miles of glacially sculpted lake country where Sinclair Lewis once stood and conceived his descriptions of Minnesota landscape. The peak, really more of a prominent hill than a mountain, sits high enough above the surrounding terrain to offer perspectives that reveal the extent of glacial modification. From the top, you can see lakes scattered in every direction, each one a kettle or depression left by melting ice, each one connected to others through the subtle drainage network that moves water from high points to low, from interior lakes to rivers, and eventually to the ocean. Lewis supposedly climbed here and saw the landscape that would inform his writing. the small towns and rural expanses that would populate his novels. The peak sits in a region of terminal moraine, where the glacier deposited material as it melted and retreated, creating the uneven terrain of hills and lakes that characterizes much of western Minnesota. The rock beneath is buried under hundreds of feet of glacial drift, sand and gravel, silt and clay, boulders and cobbles, all mixed together in the chaotic deposits typical of ice margin environments. The view from the top encompasses human geography as well as physical, farm fields and small towns, highways connecting communities, water towers and grain elevators marking where people have concentrated their presence. But the underlying pattern is still glacial, still determined by where ice left its deposits and where melting created the basins that now hold water. The Kawashiwi River flows 87 miles through the boundary waters, dropping 400 feet through dozens of rapids and connecting chains of lakes in a water highway that Ojibwe peoples have traveled for centuries. The river serves as both connection and barrier. It links lakes that would otherwise require difficult portages, but it also creates rapids that force paddlers out of their canoes to carry around sections too turbulent or shallow to navigate safely. The name is Ojibwe, preserved through the transition from indigenous to European mapmaking, maintaining the original designation in a landscape where many features acquired new names reflecting later arrivals. The river's character changes with water levels. Spring melt creates powerful currents and standing waves in rapids, while late summer often brings low water that exposes rocks and makes some passages difficult or impossible. The riverbanks are lined with boreal forest, black spruce and jack pine predominating in the poorly drained areas, with paper birch and aspen on better soils. The river has cut down through ancient bedrock in some places, creating small gorges where granite walls rise on both sides. In other sections, it meanders through wetlands where the channel is barely defined, where water spreads across low-lying areas and the current becomes difficult to detect. To follow the Kawashiwi is to experience the range of what rivers can be, from placid lake connections to turbulent rapids, from wide marsh meanders to narrow rocky channels, from clear pools where you can see bottom 20 feet down to tannin-stained sections where the water runs dark as tea. Fort Snelling sits at the confluence of the Minnesota and Mississippi rivers, where the meeting of these waters creates a geographic focal point that has drawn human settlement for at least 9,000 years. This location offers strategic advantages: control over river traffic on both waterways, access to resources from two different watersheds, a position that allows observation in multiple directions. Archaeological evidence shows that people recognized this confluence as significant long before Europeans arrived to establish a military fort. The Dakota people called the area Bdot, considering it sacred, the place where their people originated according to traditional stories. The fort itself was built in the 1820s, a stone structure designed to project American military power into territory that was still contested between nations and between the United States and indigenous peoples who had lived here for millennia. The rivers meet without drama. The Minnesota enters the Mississippi from the southwest, its turbid water mixing gradually with the Mississippi's clearer flow, creating visible current patterns for miles downstream. The confluence sits in a valley carved by catastrophic glacial floods, oversized for the modern rivers it contains, its walls rising 200 feet on both sides to mark where ancient torrents flowed. Today, highways and urban development surround the area, but the confluence continues its function, two rivers joining their waters, combining their histories and their watersheds into a single downstream flow that will carry their mingled waters all the way to the Gulf of Mexico. The Sawtooth Mountains along Lake Superior's shore contain peaks that rise 1,000 to 1,500 feet above the lake within just a few miles, creating the steepest sustained terrain in Minnesota. This is landscape tilted toward drama, where elevation changes compress into short horizontal distances, where hiking trails gain altitude quickly, where views open up to show the lake spreading vast and blue far below. The mountains aren't a range in the traditional sense. They're really a dissected plateau, an upland that rivers have carved into separate peaks and ridges through millions of years of erosion. The rock is volcanic, part of the ancient rift system that tried to split the continent, and the peaks mark where resistant flows have eroded more slowly than the surrounding terrain. The name comes from the profile, a series of peaks resembling the teeth of a saw when viewed from the lake, each peak rising to roughly similar heights. The valleys between them cut deep by streams rushing toward Superior. Snow falls heavily here, lake effect precipitation generated when cold air crosses the warmer water of Superior and then rises as it encounters the mountains, cooling and releasing its moisture. Winter snowpack can measure in feet rather than inches, persisting well into spring at higher elevations. The mountains create their own weather patterns, generating fog and rain, blocking or channeling winds, creating microclimates that vary dramatically over short distances. To hike here is to climb through life zones, starting in forest near the lakeshore and ascending into more exposed terrain where trees become stunted, where alpine species appear hundreds of miles south of their usual range, where the combination of elevation and lake influence creates conditions found nowhere else in the state. Big Stone Lake forms 26 miles of the Minnesota-South Dakota border, occupying the bed of ancient glacial River Warren that once carried the catastrophic drainage of Lake Agassiz southward. The lake is long and narrow, filling a valley carved by volumes of water, far exceeding anything that flows here today. The current lake is relatively shallow, filling only the deepest part of the ancient river channel, the rest of the valley now occupied by marshes and agricultural land. The lake's name comes from a large granite boulder that once sat prominently near the shore, significant enough to serve as a landmark for indigenous peoples and early European explorers. The boulder has since been moved to a nearby park, but the name persists. The lake marks the headwaters of the Minnesota River. Water flowing south from Big Stone will eventually reach the Mississippi and the Gulf of Mexico, while water just a few miles north flows to the Red River and ultimately Hudson Bay. This divide passes almost unnoticed through terrain so flat that determining flow direction requires surveying equipment. But it represents one of North America's major hydrological boundaries. The lake itself is popular for recreation, fishing, boating, waterfowl hunting. Activities that take advantage of the water without necessarily considering the geological history it represents. But the history is there in the valley's proportions, in the width that seems wrong for such a modest lake, in the flat valley floor that marks where torrential flows once ran. The Rum River flows 145 miles from Mille Lacs Lake to the Mississippi River at Anoka, dropping only 120 feet along its course, creating a slow, meandering path through extensive wetlands. This is a river that takes its time, that curves and loops through low-lying terrain, that floods regularly because it has so little gradient to move water quickly downstream. The name supposedly comes from a misunderstanding. Early European explorers or mapmakers confused the Ojibwe name for the river with their word for rum, and the mistranslation stuck. The river moves through landscape that was once extensive wetlands and wild rice beds, places where water spread across the land rather than concentrating in defined channels. Much of this wetland has been drained for agriculture, confined behind dikes and levees, forced into narrower channels than the river historically occupied. But the river remembers its old character. Given heavy rainfall, it still spreads across floodplains, still inundates areas that official maps call dry land, still behaves like a river with insufficient gradient to stay within its assigned channel. The slow current means the water is often turbid, carrying suspended sediment that gives it a brown or yellow color, depending on recent weather. Aquatic vegetation grows thick in the slower sections, cattails and rushes marking the edges between water and land. The river was important for logging in the 19th century, carrying logs cut in the northern forests downstream to sawmills at the river's mouth. Today, it flows more quietly, its industrial past largely forgotten, its current use more recreational, canoeing, fishing, simple appreciation of water moving gently through landscape. Niagara Cave near Harmony extends through 1.5 miles of mapped passages carved by an underground stream through 450-million-year-old limestone, including a 60-foot waterfall inside the cave system. This is darkness made navigable, void space created by dissolution, rock removed one molecule at a time by slightly acidic water percolating through cracks and fissures. The cave formed in stages. First, the creation of small voids where water could flow, then gradual enlargement as more water moved through the same passages, then the development of larger chambers where structural support allowed spans wider than the typical passages. The underground waterfall exists because a resistant layer created a drop where softer rock above and below eroded more quickly. The water falls through darkness into a pool that has never seen sunlight, creating sound that echoes through passages with no surface equivalent. The formations here, stalactites hanging from ceiling, stalagmites rising from floor, flowstone coating walls, draperies hanging in translucent sheets, all grow at rates measured in centuries per inch. Each formation represents thousands of years of deposition. Calcite dissolved from the limestone above and reprecipitated in the void spaces below. The cave's temperature remains constant because the rock mass surrounding it acts as thermal ballast, absorbing heat in summer and releasing it in winter, creating an environment more stable than anything on the surface. To enter is to leave behind not just light, but all the fluctuations that define surface existence. Temperature swings, weather changes, seasonal cycles, all cease to matter in the cave's unchanging environment. The Namaji River watershed drains clay-rich glacial deposits in eastern Minnesota, carrying so much sediment that it contributes more suspended material to Lake Superior than any other tributary, despite being relatively small. The river's water often runs red or brown with suspended clay particles, giving it an appearance more like chocolate milk than clear water. This sediment comes from the easily eroded clay deposits left by glacial Lake Duluth, an ancestor of Lake Superior that existed in the waning stages of the last ice age. The clay was deposited in quiet lake waters, fine particles settling slowly to create beds that are now exposed to surface erosion. When rain falls on these deposits, the clay particles wash easily into streams, creating turbidity that persists for days after storms. The river enters Lake Superior near Superior, Wisconsin, its plume of sediment-laden water visible extending into the lake, gradually mixing with Superior's clear waters. The sediment represents the ongoing reworking of glacial deposits, material that was transported by ice, deposited in glacial lakes, and is now being transported again by rivers toward its eventual resting place in the depths of Lake Superior. The process will continue for thousands of years, slowly moving the clay from land to lake, gradually lowering the landscape as particles wash away. It's a visible demonstration of erosion in action, of how landscapes change, of how water and gravity collaborate to move material from higher to lower elevations. Upper Red Lake and Lower Red Lake together form Minnesota's largest lake entirely within state borders, covering 288,000 acres with an average depth of only 8 feet. This combination of size and shallowness creates a lake with unique characteristics: vast area but limited depth, extensive shoreline, but nowhere to go to find truly deep water. The shallowness means the lake responds quickly to wind, waves building height without the dampening effect of deep water. It also means the lake is highly productive biologically. Light penetrates to the bottom across most of its area, allowing aquatic plants to grow, creating habitat and food sources that support large fish populations. Red Lake is the only lake in the lower 48 states where the entire lake and surrounding watershed remain under tribal jurisdiction. The Red Lake Band of Chippewa maintains complete authority over both land and water. This has allowed the tribe to manage the walleye fishery according to conservation principles rather than maximum harvest, closing the fishery entirely for several years in the 1990s and 2000s to allow populations to recover from overfishing. The strategy worked. Walleye numbers rebounded, and the fishery reopened under careful management. The lake's name comes from its appearance. The shallow water often takes on reddish or pinkish tints, perhaps from algae or from iron oxides in suspension, creating colors unusual for lakes. The lake sprawls across northwestern Minnesota, its size dominating the landscape, its presence visible for miles, its influence extending through the communities that have grown along its shores. The Crow Wing River flows 175 miles through central Minnesota, joining the Mississippi River near Brainerd, where its confluence created a major gathering point for Dakota and Ojibwe peoples before European contact. This location offered resources from multiple watersheds, access to travel routes in several directions, fish from both rivers, hunting in the forests and prairies that met in this region. The river's name is a translation from either Dakota or Ojibwe, referring to an island at the confluence that supposedly resembled a crow's wing in shape. Archaeological evidence shows continuous occupation of this area for thousands of years. People recognized the confluence as significant long before written records began documenting human presence here. The river itself has a gentle gradient, meandering through glacial terrain where moraines and outwash plains create a landscape of low hills and scattered lakes. The water is typically clear, though it carries some tannin staining from northern bogs in its headwaters. The river was important for logging, carrying cut timber downstream to sawmills, but that industry has faded, leaving the river to move quietly through a landscape where agriculture and forest coexist. Today, the confluence remains significant, though for different reasons: recreational rather than subsistence, historical recognition rather than active use as a gathering point. But the geography hasn't changed. Two rivers still meet, their waters still combine, the location still marks where watersheds and travel routes intersect. Duluth sits on steep terrain where the city's highest point reaches 800 feet above Lake Superior's surface, with some streets climbing grades of 20% or more. This is a city built on hillsides that seem to argue against development, slopes steep enough that houses perch on terraces carved into the hillside, streets switch back to gain elevation. Winter, driving becomes an exercise in faith and friction. The terrain was created by volcanic activity over 1 billion years ago. Lava flows stacking to create a thick sequence of igneous rocks, then tilted by later geological events, creating the steep face that rises from the lakeshore. The city's downtown occupies a narrow, flat area right at the lakefront, but neighborhoods extend up the hillside, climbing the slope in terraces and roads that gain elevation quickly. The steep terrain creates dramatic views. From the higher neighborhoods, you can see across the entire breadth of the lake's western arm, watch storms approach across miles of open water, observe ships entering and leaving the harbor far below. But it also creates challenges: erosion on steep slopes, difficulty maintaining roads and utilities, the constant work of keeping structures stable on terrain that wants to move downhill. The city exists in part because of the natural harbor where the St. Louis River enters Superior, and in part because of the iron ore discoveries that created a need for port facilities to ship ore to steel mills down lakes. The terrain made development difficult, but not impossible. And the result is a city with personality defined by its topography, where elevation matters, where up and down are not just directions, but defining characteristics of daily life. The Des Moines River begins in southwestern Minnesota, flowing south for 525 miles through Iowa before joining the Mississippi, draining over 900 square miles of Minnesota prairie and farmland. This is a river that starts small, gathering water from hundreds of square miles of agricultural land, growing gradually as tributaries add their flow. The headwaters region is some of Minnesota's flattest terrain, former prairie now almost entirely converted to row crop agriculture. The river here is young in terms of its current configuration. The present channel formed after the last glaciation as melting ice and changing drainage patterns established new flow routes. Before glaciation, different drainage networks existed here, rivers flowing in different directions through valleys that are now buried under glacial deposits. The modern Des Moines River follows a course determined by the topography the glaciers left behind, finding the path of steepest descent through terrain that appears nearly level to the eye, but contains subtle slopes sufficient to direct water flow. The river's contribution to the Mississippi is modest compared to major tributaries like the Missouri or Ohio, but it represents an important connection between Minnesota and Iowa, a hydrological link between states. The water that falls as rain on Minnesota farmland will eventually mix with water from rivers draining the Rockies, the Great Plains, the Appalachians, all these diverse sources combining in the Mississippi's flow toward the Gulf. Itasca State Park preserves 32,000 acres surrounding Lake Itasca, containing over 100 lakes within park boundaries and protecting 2,000 acres of old-growth pine forests. The park was established in 1891, making it Minnesota's oldest state park, created partly to protect the Mississippi's headwaters and partly to preserve the pine forests from logging. The old-growth pines here are survivors. Most of Minnesota's pine forests were cut in the logging boom of the late 1800s and early 1900s, but these trees escaped, protected by the park's establishment before cutting could occur. Today, they stand several feet in diameter, their trunks rising straight for 50 feet before branching, their canopy filtering light and creating the dim, cathedral-like atmosphere characteristic of old-growth forests. The park's landscape is typical of glaciated terrain: low hills, countless small lakes, areas of poorly drained wetland where black spruce and tamarack grow. The 100-plus lakes within park boundaries are all glacial features, kettles and depressions left as the ice melted and retreated. Lake Itasca itself is relatively small for such a famous lake, covering less than 2 square miles. Its significance coming not from size but from its role as the source of the continent's great river. The park receives visitors from around the world. People come to see where the Mississippi begins, to walk across the river on stepping stones, where it's narrow enough to step across. But the park offers more than just the famous lake. It's a preserve of landscape, a protected example of what much of northern Minnesota looked like before logging and agriculture transformed it, a place where ecology and history intersect in forests that remember what came before. The St. Croix Kettle River system drains 7,760 square miles, creating the largest tributary to the Mississippi River that originates entirely in Minnesota and Wisconsin. This is water from two states combining into a single flow. The Kettle River joining the St. Croix well upstream of where the St. Croix itself meets the Mississippi. The watershed spans diverse terrain: boreal forest in the north, hardwood forests, and agricultural land farther south, urban areas near the Twin Cities. Water falling as rain or snow anywhere in this vast area will eventually find its way through the network of tributaries and streams to these two main rivers, and from there to the Mississippi. The system represents a significant contribution to the Mississippi's flow, enough water that during spring melt the combined volume can raise the Mississippi's level measurably downstream. The rivers themselves have different characters. The Kettle moves quickly through rocky terrain, creating rapids and waterfalls, while much of the St. Croix flows more gently through wider valleys. But both share the basic work of drainage, of moving water from the land toward the ocean, of connecting the place where rain falls to the distant Gulf, where that water will eventually mix with salt. The watershed boundaries are defined by subtle elevation differences, ridgelines that may rise only a few dozen feet above surrounding terrain, but are sufficient to determine whether water flows to this system or to neighboring watersheds. It's a reminder that landscape is organized by gravity, by the simple rule that water flows downhill, seeking the lowest path toward the sea. Two harbors on Lake Superior's north shore sits where the Sawtooth Mountains meet the lake, with ore docks extending into water 400 feet deep, just a quarter mile from shore. This juxtaposition of mountain and depth creates a coast where land drops steeply, both above and below the waterline, where the drama of elevation gain on shore continues beneath the surface, as the lake bed plunges to depths that would swallow 40-story buildings. The ore docks were built for shipping iron ore from the Mesabi Range to steel mills on the lower Great Lakes, massive structures designed to load freighters quickly with thousands of tons of ore. The docks still stand, monuments to an industrial era that has largely passed, their presence a reminder of when Minnesota's north supplied the raw material for America's industrial expansion. The town's name is straightforward. Two natural harbors provided sheltered anchorage for ships, unusual along a coast where most of the shoreline offers no protection from Superior's storms. The deep water offshore meant that large ships could approach close to land, could load at the docks without fear of running aground, could depart fully laden into water deep enough to float vessels drawing 30 feet or more. The combination of mountain backdrop and deep water access made this a natural location for port development, geography creating opportunity that human industry exploited. Today, the harbor remains active, though less busy than in its peak years, the ore docks standing as reminders of the relationship between geological resource extraction and Great Lakes shipping. The Straight River in southeastern Minnesota flows through Mystery Cave's underground passages for portions of its length, disappearing below ground and re-emerging downstream in a pattern that confuses simple mapping. This is karst topography, where limestone bedrock contains caves and passages that allow water to flow underground, where surface streams can vanish into sinkholes and reappear miles away at springs. The river doesn't follow a single continuous channel. It braids between surface and subsurface routes, sometimes flowing in open air, sometimes hidden in caverns no surface observer can see. During low flow periods, more water travels underground, while during floods, the cave passages can't handle the volume and water backs up to flow on the surface. The river's name suggests straightness, but that refers to its general direction rather than its path. The actual route includes all these diversions through cave systems, creating a journey more complex than the name implies. The water moving through the caves is doing geological work, slowly dissolving the limestone, gradually enlarging the passages, creating new voids that will eventually become new caves. This is landscape in flux, though the changes occur too slowly for human observation. The rock being removed one molecule at a time, the passages growing incrementally, the underground geography shifting in ways that won't be apparent for thousands of years. The river knows only that it's flowing downhill, following whatever path gravity and geology provide, indifferent to whether that path lies above or below the surface. Lake Superior's Minnesota waters contain over 40 known shipwrecks, with some vessels resting in water so cold and fresh that wooden ships remain remarkably preserved after 150 years. The cold is part of it. Superior's deep waters never warm above 40 degrees Fahrenheit even in summer, temperatures that slow bacterial decay to near stillness. The freshness matters too. Without salt to accelerate corrosion and without marine borers to eat wood, ships can remain largely intact, ghostly presences on the lake bed, their hulls and masts and rigging preserved in the dark and cold. Some of these wrecks are accessible to divers, though the depth and cold make such diving technical and dangerous. Others lie too deep for recreational access, resting in water hundreds of feet down, visited only by researchers with specialized equipment. The wrecks represent different eras of Great Lakes shipping: wooden schooners from the 1800s, steel steamers from the early 1900s, ore boats and cargo vessels from more recent decades. Each went down for its own reason: storms, collisions, structural failure, human error. But all share the same resting place: the lake bed that receives whatever the surface cannot hold. Superior is often called the graveyard of the Great Lakes, a title earned through hundreds of lost vessels, through sailors who never made port, through the lake's capacity to generate storms of oceanic violence. The wrecks lie scattered across the Minnesota bottomlands, some marked on charts, others lost to memory, all of them reminders that even fresh water, even inland lakes, can be as unforgiving as any ocean. The Cloquet River drops 900 feet, over 70 miles, as it flows from its headwaters to Lake Superior, creating numerous rapids and waterfalls, including the 40-foot drop at Oldenburg Point. This is a river in continuous descent, always falling, always working downward through terrain that tilts toward the lake. The gradient creates energy, force concentrated in falling water, power that 19th century industrialists harnessed to run sawmills and paper mills along the river's length. Many of these industrial sites remain, though the mills themselves have often been replaced or modernized beyond recognition. The falls at Oldenburg Point represent the river's most dramatic single drop, water plunging over volcanic bedrock in a cascade that creates mist and sound, audible from considerable distance. The rock here is the same North Shore volcanic group that appears all along Superior's Minnesota coast. Lava flows from the mid-continent rift, stacked in thick sequences. The river has been working to erode through these flows for thousands of years, exploiting fractures and weaknesses, gradually cutting its channel deeper. The process continues. Each flood moves more rock. Each winter's freeze-thaw cycle breaks more stone. Each year, the river cuts imperceptibly deeper. The work is patient and continuous, unstoppable given sufficient time. The river will eventually reduce all these falls to rapids, and the rapids to gentle riffles, though that transformation lies tens of thousands of years in the future. For now, the falls remain, celebrating the river's descent, marking where hard rock resists but cannot ultimately prevent the water's path toward the lake. Minnesota's southeastern corner escaped the most recent glaciation, creating the driftless area where stream erosion rather than ice sculpted a landscape of deep valleys and narrow ridges. This is terrain that looks fundamentally different from the rest of Minnesota. No kettles or moraines, no erratic boulders perched on hillsides, no lakes scattered across the surface. The ice stopped just short of this region, its southern margin lying a few miles to the north and west, leaving this corner untouched by the glacial processes that shaped the rest of the state. Without glaciers to scrape the landscape flat, stream erosion has been working here for hundreds of thousands of years, carving valleys down through layers of limestone and sandstone, creating relief that can exceed 400 feet from ridgetop to valley floor. The valleys are steep-sided, the ridges narrow and winding, the whole landscape dissected into a complexity that glaciated terrain rarely achieves. The streams here flow clear over limestone beds, their courses established long before the last ice age, continuing in patterns uninterrupted by glacial disruption. The vegetation reflects the topography. Hardwood forests on north-facing slopes where moisture lingers, oak savanna on south-facing slopes that receive more sun and dry more quickly, prairie remnants on the driest ridgetops. This is landscape that remembers a longer history, that wasn't reset by ice 12,000 years ago, that has been developing continuously for timescales that make the ice age seem like a brief interruption. The driftless area exists as an island of older topography, surrounded by the glaciated terrain that covers most of the upper Midwest, different in character because of what didn't happen here. Lac Qui Parle Lake on the Minnesota River covers 7,500 acres when full, creating a reservoir where the lake, river, and extensive wetlands form a landscape of transition between water and land. The lake's name is French, supposedly meaning lake that speaks, referring either to echoes off the valley walls or to the sound of waves and wind across the water. The exact origin is lost to time and translation. The lake is an impoundment, created by a low dam that raises the river level, flooding the valley and creating shallow open water, where marshland and meandering river channels previously existed. This flooding created habitat valued by waterfowl, making the area an important stop on migration routes, a place where geese and ducks congregate by the thousands during spring and fall passage. The shallowness means vegetation grows extensively, cattails and reeds, wild rice and pondweeds, creating the transitional zones where water and land blend together. These edges between elements are biologically productive, supporting populations of fish and amphibians, insects and birds, all the species that thrive in environments that are neither fully aquatic nor fully terrestrial. The lake sits in the Minnesota River's oversized valley, that remnant of glacial river Warren, occupying a tiny fraction of the space the ancient torrent once filled. The valley walls rise on both sides, distant reminders of the flood's extent, marking boundaries the modern lake never approaches. The Pigeon River forms 40 miles of Minnesota's border with Ontario, dropping 120 feet at high falls of the Pigeon River, the highest waterfall on the state's northern border. The falls occur where the river encounters resistant rock in a landscape generally worn low by millions of years of erosion. The drop is dramatic enough that early fur traders had to portage around it, carrying their canoes and goods on a trail that avoided the falls and rapids. This portage became known as Grand Portage, giving its name to the trading post established at the river's mouth on Lake Superior, creating a landmark that would shape exploration and commerce in the region for decades. The falls themselves are impressive, not just for height, but for volume. The Pigeon drains a substantial watershed, and during spring, the volume of water pouring over the falls creates a roar that carries for miles. The river forms the border almost by accident. Treaty negotiators drew lines on maps without fully understanding the terrain, and the river happened to lie where they placed the boundary. But geography rarely respects political divisions, and the river flows without regard for which nation claims its waters. Wildlife crosses the border in both directions. Fish swim upstream from Superior regardless of nationality. Birds nest on both banks. The falls mark a barrier to fish migration. Species that spawn in streams above the falls must have always done so, isolated from superior populations by the barrier the falls create, while species below the falls have never accessed the upstream reaches. This creates genetic separation, populations on either side of the falls diverging slowly across thousands of generations. Bald Eagle Lake in Ramsey County reaches depths of 107 feet, making it one of the deepest lakes in the 7-county Twin Cities metropolitan area, despite covering only 1,800 acres. This depth creates different thermal characteristics than shallow lakes. The deeper water remains cold, even through summer, stratifying into layers that don't mix until fall turnover. The deepest water reaches temperatures that would feel shockingly cold to swimmers accustomed to shallow lakes that warm throughout their volume. The lake sits entirely within suburban development, its shores lined with homes and parks, its waters popular for fishing and recreation. Yet the depth creates habitat that feels remote from the surface activity. The bottom at 107 feet exists in perpetual darkness, temperatures barely above freezing. No oxygen, because the depth prevents mixing with surface waters that exchange gases with the atmosphere. This deep zone is nearly biologically dead, too cold and oxygen poor to support fish or most other life. But the shallower waters above the thermocline teem with activity. Walleye and northern pike, panfish and bass, all thriving in the lake's productive waters. The lake's depth likely reflects the character of the glacial ice block that melted to create it, a particularly large, thick section of ice that took years to melt completely, its weight pressing deep into the underlying sediments, creating a depression that filled with water once the ice disappeared. Today, the lake maintains its depth despite the urban environment around it, a pocket of cold, dark water beneath the recreational surface. The Whitewater River in southeastern Minnesota has carved a valley 400 feet deep through limestone and shale layers, creating a miniature canyon system within Whitewater State Park's boundaries. This is driftless area topography, stream erosion working uninterrupted by glaciation, cutting down through rock layers that record ancient seas and coastal environments. The valley walls rise steeply, forested slopes climbing from the narrow valley floor to ridge tops that offer views across miles of dissected terrain. The river itself flows clear over limestone beds, tumbling through rapids where resistant layers create drops, pooling in calmer sections where the gradient eases. The valley creates a microclimate distinct from the surrounding uplands, cooler in summer because cold air settles in the valley bottom, warmer in winter because the valley walls provide shelter from wind. These conditions allow plant species to persist here that wouldn't survive on the more exposed ridgetops, creating pockets of diversity in protected sites. The valley is young in geological terms. The river has been cutting for perhaps a few 100,000 years. creating 400 feet of relief in that time through the slow, patient work of flowing water. The work continues. Each flood carries more sediment downstream. Each freeze-thaw cycle loosens more rock from the valley walls. Each year the valley deepens by amounts too small to measure but real nonetheless. Given sufficient time, the valley will deepen until the river reaches base level, until it can cut no deeper, until it achieves equilibrium with the Mississippi River it flows into. But that end point lies far in the future, and for now, the river continues its work, deepening and widening its valley through the quiet persistence of water flowing downhill. Glacial Lake Grantsburg covered much of northwestern Minnesota 12,000 years ago, leaving behind rich clay soils that now form some of the state's most productive agricultural land. The lake was an arm of the much larger glacial Lake Agassiz, a separate basin that formed when ice blocked drainage routes, creating a temporary body of water that persisted for centuries or millennia before finding an outlet and draining. While the lake existed, fine clay particles settled slowly through the still water, accumulating in layers that would eventually reach considerable thickness. When the lake drained, these clay deposits were exposed to the atmosphere, available for plant growth, possessing characteristics that make them exceptionally fertile. Clay holds nutrients that sandy soils can't retain, holds moisture through dry periods that would parch coarser soils, creates conditions that favor the deep-rooted grasses that evolved on prairies. When European settlers arrived and began plowing, they discovered soils that would grow crops reliably, that could withstand drought better than sandy soils, that rewarded cultivation with high yields. Today, this former lake bed grows corn and soybeans, wheat and sugar beets, its productivity derived directly from its lacustrine origin. The landscape is flat. Lake bottoms rarely have relief, and this flatness creates its own challenges, primarily with drainage. Water has nowhere to go quickly when rain falls on perfectly level terrain, creating wetness that delayed spring planting, creating conditions that favored wetland plants over agricultural crops. Most of these wetlands have been drained through elaborate tile systems that move water artificially toward outlets, converting the natural wetland landscape into drier agricultural fields. But the underlying reality remains. This is a former lake bottom, and water still wants to pool here, still finds reasons to spread across the surface whenever drainage systems fail or become overwhelmed. The Cottonwood River flows 150 miles across southwestern Minnesota, draining an entirely agricultural watershed where virtually every acre was once tall grass prairie before settlement. This is landscape transformed completely, converted from native grassland to row crops, from perennial vegetation to annual planting and harvest cycles. The river itself has been modified, channelized in places to straighten its meandering course, ditched to drain adjacent wetlands, managed to move water quickly off farmland to prevent flooding that would damage crops. Yet the river persists, still flowing along the same basic route it followed before settlement, still draining the same watershed, still carrying water toward the Minnesota River. The water is different now. It carries more sediment from tilled fields, more nutrients from fertilizer applications, more herbicides and pesticides than pre-settlement streams contained. The river's biology has shifted. Some species declined or disappeared when the prairie was plowed, when wetlands were drained, when the river's natural character was altered. But other species adapted or increased, taking advantage of new conditions, filling niches created by the transformation. The river valley still marks a depression in the landscape, still creates slight relief in otherwise flat terrain, still provides a corridor where trees grow in a region that would naturally be grassland. Cottonwoods line the banks, the river's namesake, fast-growing poplars that colonize disturbed sites, that thrive in the periodic flooding that comes with living adjacent to a prairie river. The valley bottom is slightly cooler and moister than the surrounding uplands, creating conditions that allow these moisture-loving trees to persist in an otherwise dry region. Lake Bemidji covers 6,420 acres, the first lake the Mississippi River flows through after leaving Itasca, wide enough that the infant Mississippi disappears into its expanse. The river enters at one end, barely recognizable as the continent's eventual Great River, still narrow enough to wade across, still clear and cold from its origin. It exits at the other end, slightly larger, having collected inflow from the lake's other tributaries, beginning to take on the character it will develop more fully downstream. The lake's name is Ojibwe, supposedly meaning lake with crossing waters, referring either to currents where waters meet or to the historic practice of crossing the lake on a particular route. The lake reaches depths of 45 feet, not dramatic, but sufficient to create cold water habitat in its deeper sections. The town of Bemidji sits on the southern shore, a community built partly on logging history, partly on tourism, partly on its role as a regional center for the surrounding lake country. The lake is less famous than Itasca, but serves an important role in the Mississippi's development. It's where the river first learns what it means to be still water rather than flowing water, where it disperses across a broader surface before gathering itself back into a channel. The lake moderates flow. During high water periods, it accepts extra volume, storing it temporarily, releasing it gradually downstream. During dry periods, it maintains flow, when the smaller streams above might slow to trickles. This buffering effect continues down the entire river system, thousands of lakes and wetlands, each playing small roles in moderating extremes, in keeping the river flowing even when local conditions would suggest otherwise. The Baptism River drops 300 feet in its final 3 miles before reaching Lake Superior, creating a cascade of waterfalls, including Ilgen Falls and the 60-foot high falls at Tedagouche. This concentration of vertical drop in such short distance creates a landscape dominated by falling water, by mist and spray, by the constant sound of descent. The river has worked for thousands of years to carve its channel through the volcanic bedrock, exploiting weaknesses, undercutting harder layers, gradually wearing the stone away. The waterfalls retreat slowly upstream as the rock beneath them erodes, as the constant pounding of falling water removes material, particle by particle. This upstream migration is typical of waterfalls. They're temporary features in geological terms, existing for thousands or tens of thousands of years before eroding away, their locations moving gradually upstream until they reach the river's source. The Baptism flows through terrain tilted toward Lake Superior, the bedrock dipping down toward the lake, creating the gradient that concentrates the elevation loss. The river above the falls section is gentler, flowing through forest and wetland, dropping slowly through landscape that doesn't yet feel the pull of the lake. But once it crosses an invisible threshold a few miles upstream, the character changes completely. Urgency appears, and the river accelerates into its final descent. The falls are most impressive during spring melt, when the river swells with snowmelt and rain, when the volume of water increases tenfold, when every ledge and drop roars with power. By late summer, the flow diminishes, exposing rock faces that were hidden under water in spring, allowing you to see the detailed structure of the bedrock the water moves across. The Buffalo River flows 180 miles through northwestern Minnesota's former glacial lake bed, meandering through terrain so flat that the river drops only 6 inches per mile on average. This almost imperceptible gradient means the river has little energy to carve a defined channel, little power to move sediment efficiently, little capacity to flow quickly even during floods. The result is a river that meanders extensively, looping back on itself in curves that sometimes approach full circles, creating oxbow lakes where the river cuts through its own loops and abandons the old channel. The landscape is agricultural: corn and soybeans, wheat and sugar beets, crops grown on the rich clay soils left by glacial lake agassiz. The river valley is barely perceptible, a subtle depression in otherwise perfectly flat terrain, often distinguishable more by the presence of trees than by any dramatic elevation change. During spring melt, the river overflows its banks regularly, spreading across floodplains that are naturally floodable, creating temporary wetlands that persist for weeks before draining back toward the channel. This flooding is natural behavior for a low-gradient river, but it conflicts with agricultural use of the floodplain, leading to efforts to confine the river, to channelize its course, to prevent the spreading that the river wants to do. The river's name supposedly comes from buffalo that historically used the valley as a travel route, though by the time European explorers arrived to record the name, the buffalo were already largely gone from Minnesota, pushed west by hunting pressure and habitat change. The river flows north, contributing to the Red River of the North, part of the watershed that drains toward Hudson Bay rather than the Gulf of Mexico. The Minnesota portion of the Red River Valley occupies the bed of ancient Lake Agassiz, creating land so level that farmers can see for miles, and minor elevation changes of 5 feet determine whether land floods or drains. This is flatness achieved through deposition, millions of tons of clay settling in quiet lake waters, spreading in perfectly horizontal layers that filled any pre-existing relief. When the lake drained, it left behind this engineered flat surface, terrain that challenges human perception because the horizon seems impossibly distant, because the sky dominates, because the land offers nothing vertical to break the view. The clay soils are rich but challenging. They hold moisture to excess in wet years, creating fields too soggy to plant, creating delays that shorten an already brief growing season. But in favorable years, these soils produce spectacular yields, rewarding farmers who can manage the timing and moisture. The valley is prone to flooding. The Red River drains north, meaning spring melt moves from south to north, often arriving at downstream locations, while ice still blocks the channel, creating backups that spread water across the valley for miles. Catastrophic floods occur regularly enough that communities along the river have built extensive levee systems, dikes that attempt to keep the river confined even when natural flow patterns would spread it wide. The valley was once primarily wetland, potholes and marshes covering much of the surface, water sitting in subtle depressions, seasonal patterns of wet and dry creating habitat diversity. Most of this has been drained, replaced by agriculture, though wetlands persist in protected areas and in sections too poorly drained even for modern tile systems to manage effectively. Cascade River drops 900 feet over 8 miles near Lake Superior, creating at least 9 major waterfalls, including the 120-foot series of cascades at Cascade River State Park. The name captures the river's character. This is water in continuous cascade, always falling, always dropping from one level to the next, never achieving the calm of a river on gentle terrain. The 900 feet of elevation loss compresses into 8 miles of river length, creating an average gradient steep enough that calm stretches are brief interludes between rapids and falls. The river cuts through volcanic bedrock, exploiting fractures and zones of weakness, carving its channel ever deeper into billion-year-old rock. The valley it has created is narrow and steep-walled, forests rising directly from the river's edge, the slope too steep for easy walking, the terrain forcing concentration on every step. The sound here is omnipresent. Falling water creates noise that drowns conversation, that becomes the background against which all other sounds register. During spring, melt the river transforms, volume increasing until the falls become nearly continuous whitewater, until spray rises high enough to coat vegetation far from the water's edge, until the roar becomes something felt as much as heard. By late summer, the flow diminishes. Rocks that were hidden under spring torrents emerge dark and water-polished. The falls separate into distinct drops rather than continuous cascades. But even at low flow, the river maintains its essential character. This is water descending, gravity expressing itself in liquid form, the inevitable movement from high elevation to low, creating beauty in the process. Lake Minnewaska near Glenwood covers 7,632 acres with 2 basins separated by a narrow channel, creating distinct lake characters where one basin reaches depths of 80 feet while the other remains shallow. The 2 basins behave almost as separate lakes despite their connection. The deep basin stratifies thermally in summer, developing cold bottom waters isolated from the warm surface, while the shallow basin remains mixed throughout its depth, temperature varying little from top to bottom. The deep basin supports cold water fish species that use the depths as refuge during summer heat, while the shallow basin grows extensive vegetation, creating habitat for species that thrive in warmer, plant-rich environments. The narrow channel connecting the basins allows water exchange, but creates something like a threshold between environments, a passage from one lake character to another. The lake's name is Dakota, supposedly meaning white water, though whether this refers to wave patterns, to clarity, or to some other characteristic is uncertain. The lake sits in glacial moraine country, surrounded by rolling hills that mark where the ice sheet's margin deposited material as it melted. The water itself is relatively clear, allowing sunlight to penetrate to significant depths, supporting plant growth and creating conditions favorable for sight-feeding fish. The lake's size makes it subject to wind effects. Waves build when strong winds blow across miles of open water, creating conditions that feel more like Great Lakes than typical Minnesota lakes, challenging small boats and creating shoreline wave action that erodes banks and beaches. The Pomme de Terre River flows 91 miles through west-central Minnesota, draining glacial moraine country where kettles and kames create an irregular landscape of hills and depressions. The name is French, meaning apple of the earth, the French term for potato. Supposedly, the river was named for wild tubers that grew along its banks, though whether these were actually potatoes or some other root vegetable is lost to history. The river drains landscape left by the glacier's southern margin, where ice paused in its retreat, where melting and advance balanced for decades or centuries, creating the chaotic terrain of terminal moraine. Kettles, depressions left by melting ice blocks, dot the watershed, many of them filled with water to create small lakes, others remaining as dry depressions where vegetation differs from surrounding uplands. Kames, mounds of glacial sediment deposited against or within ice, create small hills scattered across the landscape. The result is terrain that's neither flat nor regularly sloped, landscape without obvious pattern, drainage networks that seem random rather than organized. The river gathers water from this confused topography, collecting from wetlands and small streams, gradually building volume as it flows toward its confluence with the Minnesota River. The gradient is gentle enough that the river meanders substantially, creating loops and curves that add distance to its route, that turn the shortest path into a longer journey of continuous curves. Minnesota Point in Duluth extends 6 miles as a natural sandbar across Superior Bay, forming the longest freshwater behemoth bar in the world and creating a protected harbor. The point is narrow, barely wide enough for the single road that runs its length, in places just a few hundred feet from lake to bay, a strip of sand and gravel separating vastly different water conditions. On the lakeside, waves build across miles of open water, creating surf that sounds oceanic, that pounds the beach with regularity, that sorts sand and stone through endless repetitions of surge and backwash. On the bayside, water lies calm, protected from Superior's waves, suitable for harboring ships and for the industrial activities that require stable water conditions. The point formed through littoral drift. Waves approaching the shore at angles push sediment along the coast, gradually extending the point across what was once open water. The process continues today, though breakwaters and harbor structures have altered natural patterns, creating accretion in some areas and erosion in others. The point supports a distinct community, residential properties along much of its length, people living on this narrow strand, with lake on one side and bay on the other, their homes subject to storms from Superior, while enjoying the protection the point itself provides. The lighthouse at the point's end marks the harbor entrance, guiding ships through the channel between the point and the breakwater, directing traffic through the only passage between bay and open lake. The Snake River in Pine County flows 90 miles through boulder-strewn channels carved through basalt bedrock, creating Class 2 and the 3 rapids at Snake River Gorge within Interstate State Park. This is water working against resistant volcanic rock, finding weaknesses, exploiting fractures, gradually deepening its channel through stone that formed from lava flows more than 1 billion years ago. The boulders in the channel are glacial erratics, rocks carried from distant locations by ice sheets and deposited here when the ice melted, now sitting as obstacles the river must navigate around. During high water, the rapids become significant, waves building where current meets stone, creating turbulence that makes the river impassable to all but experienced paddlers. During low water, the river quiets, exposing rocks that were submerged during spring flows, allowing easier passage but requiring careful route finding through the boulder garden. The gorge walls rise on both sides, showing the layered structure of multiple basalt flows, each layer representing a distinct volcanic event from the mid-continent rift. The rock is dark gray to black, dense and fine-grained, harder than most of the sedimentary rocks found elsewhere in Minnesota. The river has made slow progress cutting through it, the gorge deepening at rates measured in inches per millennium, patient erosion working on timescales that dwarf human history. The sound here during high flow is constant, a rushing that fills the gorge, echoing off rock walls, creating an acoustic environment dominated by moving water. Lake Carlos near Alexandria reaches a maximum depth of 163 feet, making it one of the deepest natural lakes in Minnesota, carved by glacial action into granite bedrock. This depth creates thermal stratification in summer, warm surface waters floating above cold, deep waters, the two layers separated by a thermocline where temperature drops rapidly. The deep water remains cold year-round, never warming above temperatures just above freezing even during the hottest summer months. This creates habitat for cold water fish species that would struggle in shallower, warmer lakes, species that can retreat to the depths when surface temperatures become uncomfortably warm. The lake's basin was carved when glacial ice, laden with rocks and debris, scraped across the bedrock, exploiting weaknesses, gouging deep where the rock was fractured or softer. The resulting depression filled with meltwater as the ice retreated, creating the lake that exists today. The depth also affects water clarity. The lake's volume dilutes nutrients, preventing the algae blooms that plague shallower, more fertile lakes. The result is water clear enough to see down 20 feet or more in the deeper sections, clarity that allows sunlight to penetrate to substantial depths. The granite bedrock visible along some shores is ancient shield rock, over 2 billion years old, among the oldest exposed stone in Minnesota. To swim in Lake Carlos is to float above depths that reach down through stories of water to a bottom that never sees sunlight, to a world of perpetual cold and darkness that exists just below the sun-warmed surface. The North Shore volcanic group along Lake Superior contains 200 distinct lava flows stacked like pages in a book, representing volcanic activity that occurred between 1.1 and 1.09 billion years ago. Each flow represents a separate eruption, a distinct event when magma reached the surface and spread across the landscape in rivers of molten rock. The flows vary in thickness, some just a few feet, others hundreds of feet thick, each one cooling and solidifying before the next flow buried it. The stack represents millions of years of repeated volcanic activity, the continent attempting to rift apart, the crust stretching and thinning until magma could rise through the fractures. The rifting eventually failed. The continent didn't split, but not before these massive volumes of lava had accumulated. Today, the flows are visible in road cuts and cliff faces along the North Shore, their layered structure obvious where weathering has picked out boundaries between individual flows. Some flows show columnar jointing, hexagonal columns formed as the cooling rock contracted and fractured in regular patterns. Others show ropey textures preserved from when the surface of the lava flow wrinkled and folded as it cooled while still moving. These textures are time capsules, preserving the moment of cooling in stone that has lasted over 1 billion years. The volcanic rock is hard and resistant to erosion, which is why it forms the dramatic cliffs and headlands that characterize the North Shore. Softer rocks would have eroded away long ago, but the basalt persists, standing proud above the lake, defying the waves that have been working to wear it down for thousands of years. Cass Lake in north-central Minnesota contains Star Island, which contains Pike Bay, which contains Hennepin Island, making Hennepin one of the rare islands within lakes within islands in the world. This nested geography creates layers of containment. The lake holds an island, the island holds a lake, that lake holds another island. A Russian doll of landscape features each contained within the next. The configuration is unusual enough that it draws attention from geographers interested in topological curiosities in places where landscape creates patterns that seem almost deliberate in their complexity. But the formation is purely natural, the result of glacial ice creating depressions and leaving elevated areas in patterns that happen to nest this way. Star Island is substantial, large enough to have roads and seasonal homes, its interior lake forming a protected body of water within the larger Cass Lake. Pike Bay is smaller, but still large enough for boating, while Hennepin Island in the center of Pike Bay is modest, barely large enough to support a few trees. The whole system sits in the headwaters region of the Mississippi, part of the lake district that characterizes this portion of Minnesota. Cass Lake itself covers 15,000 acres, its shoreline irregular with bays and peninsulas, its waters relatively clear and deep enough to stratify thermally in summer. The lake was named for Lewis Cass, a territorial governor and politician, though the indigenous name predates that designation by centuries. The Otter Tail River flows 200 miles from Otter Tail Lake to its confluence with the Bois de Sioux River, where the two streams merge to form the Red River of the North. This confluence is significant. It marks the birth of a river that will flow north through North Dakota and Manitoba before reaching Hudson Bay, draining a vast watershed through some of the flattest terrain in North America. The Otter Tail provides the eastern headwaters of this system, draining lake country in west-central Minnesota, gathering water from hundreds of square miles of glaciated landscape. The river's name describes its shape. Supposedly, when viewed from above, the lake and river together resemble the tail of an otter, though whether this was the original intent of the Ojibwe name or something lost in translation remains unclear. The river drops gradually through its 200 miles, creating a gentle gradient that allows extensive meandering, the channel looping back on itself in curves that double or triple the straight-line distance. The river was important historically for transportation and mill power, its flow harnessed to grind grain and saw lumber, though those industrial uses have largely ceased. Today, the river moves quietly through agricultural and forested landscape, its banks lined with hardwoods and conifers depending on latitude, its water carrying the typical load of sediment and nutrients from its diverse watershed. At the confluence with the Bois de Sioux, the Otter Tail's southward flow meets northward flowing water, and the combined stream turns definitively north, beginning the Red River's long journey toward Hudson Bay and the Arctic Ocean. Mound Springs Cave near Spring Valley extends 3,500 feet underground, its passages carved by acidic groundwater dissolving 450-million-year-old limestone beneath Minnesota's prairie landscape. The cave exists in a region where limestone bedrock lies close enough to the surface that groundwater moving through it can create substantial cave systems. The formation process is patient. Water percolating through soil picks up carbon dioxide, becoming mildly acidic, enough to slowly dissolve calcium carbonate in the limestone. Over thousands or millions of years, this dissolution creates voids, passages that gradually enlarge as more water flows through, until they become caves large enough for human exploration. The cave temperature remains constant, the rock mass too large to respond to surface temperature changes, creating an environment that stays perpetually cool regardless of season. The formations here grow slowly, stalactites hanging from the ceiling, stalagmites rising from the floor, flowstone coating walls and mineral deposits, all accumulating at rates that make patience seem hasty. Each formation represents thousands of years of drip-by-drip deposition, calcite dissolved from the limestone above and reprecipitated in the void spaces below. The cave is still active, water still flows through it, still works on enlarging passages, still deposits new formations, though the changes occur too slowly for any human observer to notice during a lifetime. The cave represents hidden geography, landscape that exists beneath the surface, void spaces that mirror in their way the surface topography, creating a shadow world of darkness and stone. Lake Winnibigoshish covers 58,000 acres in north-central Minnesota, created when a dam raised the natural lake level by 8 feet, flooding extensive wild rice beds that once covered shallow bays. The lake's name is Ojibwe, supposedly meaning miserable, wretched, dirty water, though whether this referred to color, taste, or some other characteristic is debated. The dam was built to regulate water levels on the Mississippi River downstream, to store water during high flow periods and release it during low flow periods, creating a more consistent river level for navigation and power generation. But the flooding changed the lake's character, drowning the wild rice beds that had provided food for indigenous peoples and waterfowl for centuries, converting shallow marsh into open water. The lake is popular for fishing, walleye and northern pike, perch and muskellunge, species that thrive in the relatively fertile waters and diverse habitat. The shoreline is mostly undeveloped, protected within the Chippewa National Forest, maintaining a wild character that's increasingly rare for large lakes this accessible. The lake sits in the transition zone between deciduous and coniferous forest, where species from different ecological communities overlap, where you might find oak and pine growing side by side. The water is tannic-stained in places where streams bring water from northern bogs, clear and green in other areas where the bottom is sandy and vegetation sparse. Winter ice fishing is popular here, the frozen surface becoming a temporary town of ice houses and vehicles, a seasonal community that disappears come spring thaw. The Redwood River flows 167 miles across southwestern Minnesota, cutting through terrain where the river has exposed Sioux quartzite formations 1.6 billion years old at Ramsey Park near Redwood Falls. This quartzite is among the hardest rock in Minnesota, originally sandstone that was metamorphosed by heat and pressure into something denser and more resistant to erosion. The pink color comes from iron oxide minerals distributed through the rock, the same compounds that create rust, here locked into stone that will persist for millions of years more. The river has carved a valley through this resistant rock, a gorge that seems disproportionate for the modest river that created it, suggesting either that the river once flowed with greater volume or that it has been working at its task for an exceptionally long time. The quartzite exposures at Ramsey Park show the tilted layers, the bedding planes that reveal this rock's sedimentary origin, the cross-bedding that records ancient currents in seas that existed over 1 billion years ago. The river valley creates relief in otherwise flat prairie landscape, a linear depression where trees grow in what would naturally be grassland, where microclimates allow species to persist that couldn't survive on the exposed uplands. The river flows generally northeast, joining the Minnesota River downstream, contributing its water to the system that drains southwestern Minnesota toward the Mississippi. The name redwood refers to the red cedar trees that grew along the river, though these weren't true redwoods, but rather junipers, the name reflecting early settlers' imperfect botanical knowledge, or simply their need to name things after familiar species from elsewhere. Pelican Lake in Crow Wing County reaches depths of 82 feet and covers 3,900 acres. Its water so clear that aquatic vegetation grows to depths of 20 feet, creating underwater forests. This clarity reflects the lake's geology and watershed. Relatively infertile soils mean limited nutrient runoff, keeping the water clear enough for sunlight to penetrate to substantial depths. The deep vegetation creates complex habitat, three-dimensional structure, where fish can hide, feed, reproduce, creating populations of game fish that draw anglers from across the region. The lake's name supposedly comes from either the pelicans that historically nested here, or from a Dakota chief, depending on which historical account you credit. The lake sits in the transition between prairie and forest, a position that historically created ecological richness, species from different communities meeting and overlapping. The water temperature stratifies in summer, warm surface waters above cold depths, the two layers separated by a thermocline that fish can navigate, but that creates distinct thermal environments in a single lake. The clarity extends beyond the vegetated zone. Even in the deepest sections, during calm conditions, you can sometimes see down 30 feet or more, observing the underwater landscape, the subtle variations in bottom composition, the occasional fish moving through. The lake freezes deeply in winter, ice reaching 2 feet thick or more, creating a platform for ice fishing and other winter activities. But even under the ice, life continues. Fish remain active in the cold water. Vegetation persists in dormant form, the lake maintaining its biological functions at a slower pace. The Rainy River forms 85 miles of Minnesota's border with Ontario. draining Rainy Lake and carrying water that began as rain or snow that fell on the boundary water's rugged landscape. This is water that has traveled through chains of lakes, over rapids and portages, through the aquatic highway that defines this northern border region. The river flows west from Rainy Lake to Lake of the Woods, dropping gradually through terrain that's flat enough to make the river slow and meandering. The current is gentle most of the year, the river spreading wide in places, creating a border that's more symbolic than defensive, a line on maps that matters to governments, but means little to the water flowing across it or the wildlife that uses it. The river was important in the fur trade era, a key link in canoe routes that connected Lake Superior to the western interior, a highway that allowed European trade goods to flow west and furs to flow east. The Ojibwe name for the river predates European contact, though the exact meaning has been debated. Some suggest it refers to the mist at Rainy Lake's falls, others to different characteristics. The river's valley is wide, perhaps carved by larger flows in the immediate post-glacial period when melting ice created temporary torrents. Today, the river moves peacefully through this oversized valley, its modest current barely suggesting the power it once might have carried. The international boundary follows the river's center channel, splitting jurisdiction down the middle, creating a shared waterway that neither nation fully controls. Blue Earth County sits atop bedrock formations containing glacial deposits 400 feet thick in places, representing multiple ice ages that advanced and retreated across southern Minnesota. These deposits are a record of climate history, written in sediment, layers of till from different glacial advances, interbedded with layers of sand and gravel from meltwater streams, occasional layers of soil or organic material from interglacial periods when the ice retreated and climate warmed enough for vegetation to establish. Each layer tells a story of conditions at the time of deposition, the character of the ice sheet, the way it moved, what material it carried. The 400 feet of depth represents hundreds of thousands of years of accumulation, multiple glaciations each adding its contribution to the pile. Beneath these deposits lies much older bedrock, Paleozoic sedimentary rocks formed in ancient seas, limestone and shale that record environments utterly unlike today's. But that bedrock is buried, invisible except where rivers or human excavations cut deep enough to expose it. The glacial deposits determine the county's modern character. They create the gently rolling topography, the till plains that farmers plow, the texture of the soil that determines what crops grow well. The deposits also control drainage. Permeability varies between layers, creating aquifers where groundwater can flow easily and confining layers that impede vertical movement. Wells drilled here must penetrate variable materials, sometimes finding water in sand layers sandwiched between clay, sometimes drilling through the entire glacial sequence to reach water in the bedrock below. Split Rock Creek in southwestern Minnesota flows 70 miles before joining the Big Sioux River, cutting through quartzite outcrops that reveal billion-year-old rock at several points along its course. These quartzite exposures are similar to those at Blue Mounds and other locations in southwestern Minnesota. Pink Sioux quartzite that formed from beach sands in ancient seas, then metamorphosed into harder rock through heat and pressure. The creek has carved its valley through this resistant material, exploiting fractures and weaknesses, creating a gorge that reveals the internal structure of the quartzite. The rock shows cross-bedding in places, preserved ripple marks and sedimentary structures that record conditions when this was loose sand rather than solid stone. The creek itself is modest, flowing clear over rocky beds during normal conditions, swelling during spring melt and after heavy rains. The valley it occupies seems oversized for the current creek, suggesting either that the creek once flowed with greater volume or that it has been working at valley formation for an exceptionally long period. The quartzite resists erosion so effectively that the creek's progress is measured in geological time, the valley deepening by amounts too small to measure in human lifetimes. The exposures along the creek are among the few places where this ancient rock is visible at the surface. Elsewhere, it's buried under younger deposits or has been eroded away entirely. The creek flows through primarily agricultural land, its watershed almost entirely converted to crops, though the steep-sided valley retains some natural vegetation. Lake Kabetogama in Voyageurs National Park covers 25,000 acres with a maximum depth of 80 feet. Its shoreline so irregular with bays and peninsulas that measuring every indentation yields over 100 miles of coast. This complexity creates habitat diversity. Each bay has slightly different conditions, different exposure to wind, different depth profiles, different vegetation. The lake's name is Ojibwe, though the exact meaning is debated, possibly referring to either the lake's character or to nearby features. The lake sits entirely within the national park boundaries, protected from shoreline development that has altered many similar lakes elsewhere. The water is clear in places, tannic-stained in others where streams bring water from northern bogs, creating variations in color and visibility depending on which section of the lake you're in. The irregular shoreline means that exploring the lake requires time. You can't see it all from one vantage point, can't understand its full extent, without actually navigating its bays and channels. Some sections feel lake-like, open water stretching to distant shores, while others feel riverine, narrow channels where banks close in on both sides. The lake connects to the larger Voyageurs system through narrows and channels, part of the aquatic highway that makes this region navigable by boat. The depth is sufficient for thermal stratification in summer, creating distinct layers where temperature and oxygen levels vary, where fish can choose habitat based on their thermal preferences. In winter, the lake freezes, its surface becoming a highway for snowmobiles, its ice thick enough to support vehicles, though caution is always warranted on lakes this large, where ice thickness can vary. The Red Lake River flows 200 miles from Lower Red Lake to its confluence with the Red River at Grand Forks, North Dakota, draining 5,900 square miles of Minnesota wetlands and agricultural land. This is a substantial watershed, gathering water from across northwestern Minnesota, channeling it toward the north-flowing Red River system that ultimately drains to Hudson Bay. The river was named for the lake it drains, which in turn was named for its distinctive water color, reddish or pinkish tints that appear under certain conditions, possibly from algae or mineral content. The river drops gradually through its length, creating a gentle gradient that allows extensive meandering, the channel looping through its valley in curves that add distance to what would be a more direct route. The watershed includes both natural wetlands and drained agricultural land, the balance between these land uses affecting the river's hydrology. Wetlands store water and release it slowly, while drained agricultural land sheds water quickly, creating higher peak flows and lower base flows. The river carries sediment from its agricultural watershed, giving it a turbidity typical of prairie rivers, a color ranging from brown to yellow depending on recent weather. The river was important historically for transportation and mill power, sites along its length developing into towns that used the river's energy to grind grain and saw lumber. Today it flows more quietly through landscape transformed by agriculture, its banks often lined with trees that mark where forest species persist in otherwise grassland or cropland environments. Tetagouche State Park's shoreline on Lake Superior includes Shovel Point, where 170-foot rhyolite cliffs drop directly into water that reaches depths of 200 feet just offshore. This is verticality both above and below the waterline, drama that continues in both directions from the surface. The rhyolite is volcanic rock, more silica-rich than the basalt that forms most of the North Shore, created from lava that was more viscous, more resistant to flow, more likely to create steep terrain. The cliffs are sheer in places, nearly vertical faces of dark rock rising straight from the lake, waves crashing at their base with force that speaks of deep water close to shore. The name Shovel Point supposedly refers to the shape. From certain angles, the promontory resembles a shovel's blade. Standing at the cliff top provides views across miles of lake, water extending to the horizon, the curvature of Earth sometimes visible in the distance on exceptionally clear days. The depth offshore is unusual. Most shorelines slope gradually into deeper water, but here the cliff continues below the surface, plunging almost as steeply underwater as it rises above. This creates conditions where waves don't break gradually, but rather crash directly against the rock face, where storm waves can throw spray high up the cliff, where the lake shows its power most dramatically. The rhyolite shows columnar jointing in places, hexagonal columns formed as the lava cooled and contracted, creating geometric patterns that seem too regular to be natural. The Watonwan River flows 100 miles through south-central Minnesota, its name meaning where fish bait abounds in Dakota language, reflecting the river's importance as a fishing ground before European settlement. This is landscape that has changed dramatically since that naming. The river valley that once supported diverse fish populations now flows through primarily agricultural land, its watershed almost entirely converted from prairie and oak savanna to row crops. The river carries the signature of this transformation: sediment from tilled fields, nutrients from fertilizer applications, herbicides and other agricultural chemicals at levels that would have been absent in pre-settlement times. Yet the river persists, still following the same basic route it carved through glacial deposits, still providing the same basic function of draining water from its watershed toward the Blue Earth River and eventually the Minnesota River. The name survives as a reminder of what was, of the river's historic character and its importance to the Dakota people who lived along its banks and used its resources. The river's gradient is gentle, typical of rivers flowing through glaciated terrain in southern Minnesota, creating extensive meandering through a valley that's wide relative to the current channel size. Trees line the banks in many places, riparian forest providing the only wooded corridors through an otherwise treeless agricultural landscape. These forested corridors serve as wildlife habitat and migration routes, linear preserves of quasi-natural conditions through terrain that's otherwise been completely transformed by human use. Long Lake in New Brighton reaches depths of 62 feet, despite being surrounded by dense suburban development, maintaining water quality sufficient for swimming and fishing within the Twin Cities metro area. This persistence of quality, despite urban pressures, reflects careful watershed management, stormwater controls that prevent excessive runoff, and perhaps some luck in the lake's particular characteristics: deep enough to dilute pollutants, large enough to handle some impact, positioned in a watershed where the worst development practices were avoided or mitigated. The lake sits entirely within suburban neighborhoods, its shores lined with homes and parks, accessible to thousands of residents who use it for recreation. Yet it maintains populations of game fish, supports aquatic vegetation, provides habitat for waterfowl and other wildlife. The depth creates thermal stratification in summer, distinct layers where the deep water remains cold even when surface temperatures rise to swimmable levels. This stratification creates habitat diversity, allowing species with different temperature preferences to coexist in different depth zones. The lake is a remnant of glaciation, a kettle formed when a large ice block melted, creating a depression that filled with water. The depth suggests the ice block was substantial, thick enough to depress the underlying sediments significantly. Today, the lake represents what's possible when development happens with some care for existing landscape features, when lakes are valued as community assets rather than obstacles to maximum density, when water quality is maintained rather than sacrificed to short-term expediency. The Brule River flows north from Judge C.R. Magny State Park to Lake Superior, dropping 200 feet in its final 3 miles, including the mysterious Devil's Kettle waterfall, where half the river disappears into a pothole. This disappearance has generated speculation for decades. Where does the water go? How does it rejoin the main channel? What happens in the darkness beneath the rock? The falls split around an outcrop, one side dropping into a visible pool below, the other side plunging into a deep pothole whose bottom isn't visible, whose exit route isn't apparent. Dye studies have confirmed that the water eventually rejoins the river downstream, but the exact path remains unclear, hidden in fractures and passages within the volcanic bedrock. The mystery adds interest to what would already be a notable waterfall. The sheer volume of water disappearing into a hole barely wider than a car creates a spectacle that defies easy explanation. The river's steep gradient in its final miles creates several other waterfalls and rapids, the river racing toward Lake Superior through terrain that tilts dramatically toward the shore. The bedrock is volcanic, dark, and resistant, creating the structural integrity necessary for maintaining the pothole and whatever passages the water follows. The disappearance isn't permanent. The water emerges somewhere downstream, but the specific route remains one of those minor mysteries that geography occasionally preserves. Details that remain unknown despite our capacity to measure and map most features. Lake Shigawa near Ely covers 2,240 acres in the gateway to the Boundary Waters, its water level raised by a dam built in the 1880s to facilitate log transport down the Shigawa River. The dam converted what was probably a smaller natural lake into a larger reservoir, flooding additional shoreline, creating the modern lake configuration. The name is Ojibwe, the specific meaning debated but persistent through the transition from indigenous to European mapping. The lake sits at the edge of the Boundary Waters canoe area, outside the protected wilderness, but connected to it by portage routes, serving as a jumping-off point for trips into the interior. The town of Ely developed on the lake's shore, growing initially as a mining community, later transitioning to tourism and wilderness outfitting as mining declined. The lake itself experienced significant environmental degradation in the mid-20th century, pollution from mining and municipal sources creating water quality problems severe enough to make headlines. But restoration efforts beginning in the 1970s have gradually improved conditions, demonstrating that even damaged lakes can recover given time and proper treatment. Today, the lake supports fishing and recreation, its waters clearer than they were at their worst. Though not approaching the pristine clarity of Boundary Waters lakes that never experienced industrial pollution, the lake serves as a reminder that geography is shaped by both natural and human forces, that landscape responds to how we treat it, that recovery is possible but requires sustained effort and time. The North Shore Highlands receive over 30 inches of precipitation annually, significantly more than most of Minnesota, creating the state's only environment where boreal forest species like caribou moss and boreal chickadees naturally occur this far south. This enhanced precipitation comes from lake effect. Air crossing. Lake Superior picks up moisture, then rises as it encounters the highlands, cooling and releasing that moisture as rain or snow. The effect is pronounced enough to create distinctly different conditions than areas just a few miles inland, creating a narrow zone where precipitation totals and ecological communities differ markedly from surrounding regions. The boreal forest here includes species more typical of Canadian latitudes: black spruce and balsam fir, paper birch and white cedar, species that thrive in cool, moist conditions, that tolerate short growing seasons, that have adapted to environments where winter dominates the annual cycle. The understory includes mosses and lichens that require high humidity, species that would desiccate in drier conditions but thrive in the North Shore's persistent moisture. The combination of elevation, lake influence, and latitude creates conditions unique in Minnesota, a pocket of northern ecology extending hundreds of miles south of its typical range. The forest here survived logging in some locations, protected by steep terrain that made harvest difficult, by remoteness that kept it uneconomic to access, by designation as state parks and protected areas that prevented cutting. Today, these remnant old-growth stands and regenerated forests maintain the boreal character, offering a glimpse of ecosystems that once extended much farther south during colder periods, that now persist here as ecological refugees from a warmer world.